všetci. Moja prvá otázka bude v angličtine. Is anyone here who can speak Slovak or Czech? No? You? So, okay. If you would like to learn something, I'll be glad if you stay here. But the first half of this presentation, the first half of the day, here in a small auditorium, will be held in Slovak language or Czech language. Okay, great. So we are happy to have you here. And now I switch to Slovak language. It's okay. Tak chcela by som, dúfam, že ste sa vyspali. Či dlho to asi nie, ale snáď aspoň dobre. A naša prvá prednášajúca je Michala Gulášová a odpovie nám otázku, či je azda MATLAB lepší ako had. Ďakujem.
Takže dobré ránko všetkým želám. V prvom rade by som sa chcela poďakovať organizátorom a všetkým, ktorí sa podielali na príprave tejto krásnej konferencie. Ako ma už kolegyňa uviedla, moje meno je Michala Gulášová, som študentkou prvého ročníka doktorandského štúdia aplikovanej informatiky a samozrejme veľká fanúšička Pythonu, hoci teda pracujem s ním ešte pomerne krátky čas. O čo vlastne pôjde v tejto prednáške? Cieľom mojej prezentácie je oboznámiť vás s možnosťami, aké ponúka Python ako náhrada namiesto MATLABu. Na záver tejto prezentácie by ste si teda každý sám mali byť schopní odpovedať na otázku, či je azda MATLAB lepší ako had. Ako vidíte na slajde, tak Python nebude jediný had tejto prezentácii. Budeme hovoriť ešte o anakonde, o ktorej vlastne poviem viac počas prezentácie. Ešte sa vás chcem spýtať, že či vlastne tu niekto taký, kto už s MATLABom pracoval. Dobre. A boli ste spokojní so všetkými možnosťami, aké vám MATLAB ponúkal? No, alebo ja som s ním pracovala ešte počas môjho bakalárskeho štúdia a nebola som s ním celkom spokojná. To si vysvetlíme vlastne počas tejto prezentácie. Teraz sa pozrime vlastne na to, čo nám MATLAB ponúka. No MATLAB, pre tých, ktorí neviete, tak je to vlastne matematické laboratórium, ktoré disponuje množstvom nástrojov pre či matematickú analýzu, štatistiku, dá sa v tom robiť machine learning, viete si robiť simulácie v Simulinku, toto tlačidlo tu hore. Jeho najväčšou nevýhodou však je, že je platený. Samozrejme, že niektorí šikovnejší z nás si ho vedia získať aj inými cestičkami, ale o tom sa baviť teraz tu nebudeme. Takže teraz si predstavme situáciu, že potrebujete ako vstup do vášho skriptu, napríklad nejakú štatistickú analýzu idete vykonať. Ja som konkrétne robila stegoanalytické útoky. Takže potrebujete spracovať automaticky veľké množstvo dát, veľa súborov. Tie dáta v tých súboroch vyzerajú štýlom, že máte napríklad čísla, desatinné čísla, ktoré sú ale není zoradené pod sebou, to znamená, že nemáte jednotky pod jednotkami, desiatky pod desiatkami a tak ďalej. Máte tam navyše nejaké prázdne riadky, tak vlastne hľadáte a googlite a nájdete, čo vám ponúka MATLAB. Tak ja som našla funkciu import data. Ak niekto pracuje s MATLABom, možno nakoniec ma bude možno vedieť aj oboznámiť s nejakými lepšími možnými riešeniami. Ja som ale našla túto funkciu. Argumentom do tejto funkcie je vlastne meno súboru, alebo teda cesta. Ďalej je to oddelovač, teda delimiter. Defaultne to myslím, že býva medzerník v MATLABe. A taktiež si môžete zadefinovať počet riadkov hlavičky, ktoré chcete preskočiť. Bežne to bývajú nejaké názvy, čo sa v tých daných stĺpčekoch nachádza. Toto si napíšete a keď to spustíte, tak zistíte, že ste není spokojní. Pretože MATLAB nevedel, respektíve nesprávne vám naimportoval tie dáta práve kvôli tým nezarovnaným hodnotám v tom súbore, že neboli jednotky pod jednotkami a tak ďalej, boli tam nejaké riadky navyše. Takže zostanete smutní a zisťujete, že čo vlastne by sa dalo miesto toho použiť, aby ste to mohli robiť nejako automaticky. No tak mne v tom čase neostalo nič iné, ako ručne si naťahať tie moje súbory sem do workspaceu cez toto tlačidlo. To sa dá ešte, keď máte tak 2-3 súbory, ale pokiaľ ich máte stovky a tisícky, ako mne neskôr pribudlo, tak to už bolo nemožné. Čiže takto to potom vyzerá, keď vlastne ručne dávate tie premenné alebo tie dáta do toho workspaceu, nastavíte si tu potom ručne ten oddelovač a ešte ten štýl ďalší, čo tam je. Takže odpovedou vlastne na tú otázku, že ako vyriešiť toto automatické načítavanie množstva dát, odpovedou sú práve tieto dva hady, a to Python a Anaconda. Pythona poznáme, Anacondu mnohí z vás pravdepodobne nepoznajú. Takže čo to je? Je to vlastne open sourceová platforma postavená na Pythone. Jej hlavným cieľom je vlastne manažment balíčkov, taktiež dokáže manažovať environmenty. Samozrejme, že je zadarmo. Je jednoduchá na inštaláciu, čiže keď som to zvládla ja, tak si myslím, že to zvládne už každý. V základnej sade, keď si ju nainštalujete, tak máte k dispozícii viac ako 150 balíčkov a celkovo Anaconda disponuje viac ako 720 rôznymi balíčkami. Ak sa vám zdá, že vlastne ten priestor, ktorý vám zaberie na disku, je príliš veľký a viete, ktoré balíčky alebo ktoré knižnice konkrétne budete potrebovať, tak si môžete nainštalovať len jej oklieštenú verziu, ktorá sa nazýva Miniconda. Čo je super na Anaconde je aj to, že okrem Windowsu podporuje vlastne beh aj pod Linuxom a taktiež vám vie bežať na Macoch. Ešte taká teraz najčerstvejšia novinka od nich je, že dokonca už sa vie integrovať aj do Excelu, čiže ak ste nejaký fanúšik alebo používateľ excelovských tabuliek, tak viete si krásne generovať kvalitné grafy aj pre tlač, aj pomocou Anacondy. Anaconda podporuje tieto všetky vývojové prostredia, medzi nimi sú vlastne Spider, potom Python pre Visual Studio, PyCharm, Eclipse, Wing, Ninja a taktiež základné pythonovské IDE, IDLE. Takže teraz viac k tomu Spiderovi, ktorý som používala a ktorý si aj ukážeme potom na praktickom príklade. Je jednoduchý na používanie, je už zahrnutý vlastne v Anaconde, to znamená, že keď si Anacondu nainštalujete, tak ste ready to use, môžete hneď začať programovať. Poskytuje základnú editáciu, ako vysvietenie syntaxe, a tom doplňanie kódu. Taktiež poskytuje nejaké základné testovanie a samozrejme, že krokovanie. A teraz trošku viac k tým jednotlivým balíčkom, ktoré budete vidieť aj v tom príklade. Takže SciPy vlastne zastrešuje všetky tie základné vedecké, inžinierské, matematické balíčky, ako sú NumPy, SciPy library, Matplotlib, IPython, teda interaktívna konzola, SymPy ako symbolická matematika a Pandy, ktoré pracujú s dátovými štruktúrami a analýzou. NumPy, teda Numerical Python, je to balíček, ktorý sa používa pre prácu s viacrozmernými objektami. Má množstvo, ale naozaj množstvo metód, tu sú len niektoré z nich. Používa sa napríklad pre lineárnu algebru, vie počítať maticové produkty, normy, viete ho využiť pre Fourierovú transformáciu, či diskrétnu, či rýchlu. Má tam dokonca nejaké základné finančné funkcie, poskytuje algoritmy pre triedenie, vyhľadávanie a najdôležitejšie asi pre ten začiatok samotný s tou prácou s Pythonom metódy pre vstupy a výstupy, o ktorých sme si hovorili. Ďalej balíček Matplotlib je balíček, pomocou ktorého vlastne viete generovať krásne 2D grafy rôzne, koláčové histogramy, všelijaké iné. Dá sa rozšíriť aj na generovanie 3D grafov. No a teraz by sme si vlastne ukázali praktický príklad, čiže tuto je nejaký môj skript napísaný v MATLABe. Tuto vlastne vidíte tie premenné, ktoré boli ručne vložené do toho pracovného priestoru, čiže workspaceu, kde sa následne vykonali nejaké výpočty. Ešte možno spomenúť, že MATLAB vlastne indexuje polia od jednotky, čo je rozdiel od Pythonu, kde indexujete od nuly. A tieto výsledky si potom uložíte do premennej. Vlastne je to ďalšia nejaká veľká matica s hodnotami a keď chcete, aby ste mali na výstupe nejaký graf, tak si znova musíte ručne kliknúť na tie hodnoty a dať vygenerovať graf. Čo je znova nešikovné, keď chcete automaticky generovať veľké množstvo grafov. Takže ukážem si teraz, ako to vyzerá v Spideri, napísané v Pythone. Neviem, Spider už niekto používal ako taký? Dobre. A Anacondu ste poznali? Áno? Super. Tak možno nič nové pre vás tu. Takže toto je vlastne ten kód, ktorý ste pred chvíľočkou mali možnosť vidieť, prepísaný v Pythone. Samozrejme, že je znova to isté, len vyzerá to trošku inak. Ale čo je dôležité, je načítavanie vlastne tuto tých vstupov, kde vlastne vidíte, že viem načítavať, ja som tam mala stovky súborov v tom jednom priečinku, takže všetky si pekne postupne cez iteráciu načítavam, vyrátam si výsledky a čo je dôležité, tak si viem hneď generovať na záver grafy. Tuto mám zakomentované, ja si to rovno spustím, lebo to dlhšie bude spracovávať, je tam veľké množstvo dát. A tuto na konci vlastne vidíte samotnú generáciu jedného grafu. Čo ešte chcem poznamenať, ak budete pracovať na nejakom výskume a budete potrebovať generovať grafy do nejakých svojich prác, bakalárok, diplomoviek alebo do článkov, tak veľmi dôležitý parameter, keď budete nahrávať ten váš graf, je práve toto DPI, čo je počet obrazových bodov na palec. A je to z toho dôvodu, že pri tlači budú od vás požadovať DPI aspoň 300. Kdežto defaultne je tento parameter oveľa nižší, neviem či okolo 100. A jednoducho tie grafy sú defaultne maličké, aby nezaberali príliš veľa miesta v pamäti. A keď si toto nadstavíte, tak vám to vlastne vygeneruje, ako budete vidieť krásny veľký graf. Ešte čo je dôležité a patrí to k takým best practices pri používaní, pri načítavaní jednotlivých balíčkov, je vlastne vyhnúť sa takémuto štýlu načítavania, kedy z PyLabu chcete importovať úplne všetky balíčky, čo zahrňa celé NumPy, Matplotlib a všetky tie ostatné ďalšie, ale importujete si konkrétne to NumPy alebo z toho z Matplotlib konkrétne len ten pyplot. Tuto vlastne vidíme už, medzi tým nám vygenerovalo ten graf. Ja vám ho nájdem tuto. Tuto nie. Tuto sú všetky tie grafy, ktoré generovalo postupne, čo som teraz zakomentovala. A môžem si ukázať aj tie. Čiže ono všetko takto postupne Hej, išlo, čiže tých grafov je veľa. A na konci vlastne vygeneroval takýto graf. Ešte si ukážeme vygenerovanie 3D grafu. Tiež ho rovno spustím. Nemusíme čakať. A tuto vlastne vidíte, ako sa dá vygenerovať cez Matplotlib 3D graf. Najskôr si spravíte mesh grid a potom vlastne zadefinujete cez etsuplot, že chcete 3D projekciu. A on vám vlastne potom vygeneruje takýto krásny 3D graf. Hej. Sú tu dva, on vždy zobrazuje v tej konzole len ten posledný vygenerovaný, čiže tento ste tam videli, ale generujú sa tam dva. No a na záver prezentácie si už len môžete prečítať krátky vtip. A ja vám týmto ďakujem za pozornosť a teším sa na nejaké vaše otázky a pripomienky a možno rady z vašej strany, ak ste skúsení už v týchto veciach ako ja. Ďakujem.
Ďakujeme veľmi pekne. Máte nejaké otázky? Pozrieme sa na slajdy. Tak. Alebo sa nepozrieme? Ešte si prečítate vtip teda. Áno.
Keď si hovorila o tom, že anakonda je podporovaná nejakými vývojovými prostrediami, tak existuje nejaké vývojové prostredie, kde môžem pracovať s Jupyterom, Buffy na
No, toto už musíš vedieť ty, že v ktorom prostredí sa to dá, lebo na tom slajde vlastne boli vypísané všetky možné, ktoré vieš použiť s tou anakondou. A naozaj netuším, ja poznám len Spider a ešte Wing. Tak refraktoring kódu? Spidery asi nie, alebo Wingu neviem, nepoužívala som to, takže neviem ti povedať, že ktoré ide.
Je tu otázka, či si skúšala iné moduly na vizualizácie grafov, ako napríklad Plotly? Ak áno, vieš ich porovnať?
A viete povedať ten druhý modul, lebo ja som... Áno? Áno, aj veľa iných. Áno.
A ono to bolo myslené ako konkurencia tej matlabskej grafy. Ak ste si všimli, tak tá syntaxia je skoro doslova tá istá.
Áno, preto v to porovnaní s MATLABom. S MATLABom.
Na 3D to myslené nebolo a videli ste, že aj ten graf bol voľaký kostropatý. No, tak na 3D myslím, že vo vašom prípade najlepší nástroj je Majavi.
Majavi?
Áno. Cez anakondu sa Majavi dá nainštalovať a tie plot 3D a iné príkazy sú veľmi podobné, ako ste tu mali. To vyzerá neporovnateľne.
Krajšie. Tak ďakujem. Ja som teda veľmi rada, že sú tu ľudia, ktorí to poznajú, lebo vlastne túto prezentáciu som chcela spraviť hlavne kvôli tomu, že v škole sa stretávam stále s tým, že ľudia používajú MATLAB a sú určitým štýlom obmedzovaní. Takže som rada, že...
A chcela by som sa ťa ja opýtať, že keby bol MATLAB zadarmo, takže či by si ho používala?
Nie. Určite nie.
Tak, máte ešte niekto nejaké otázky? Áno, tu vzadu. Ešte niekto? Áno?
Čím sa vlastne zaoberáš na svojom PhD?
Steganografia. Hovorí vám to niečo?
Ani nie.
Áno, je to vlastne ukrývanie tajných správ do multimédií a ja sa konkrétne zaoberám do obrázkov. ukrývanie, steganografia, stegoanalýza, čo je potom detekcia tých správ ukrytých v tých obrázkoch. Tak, narýchlo vysvetlené. Tie algoritmy som si robila ručne, takže nepotrebovala som spracovanie obrazu ako takého ešte zatiaľ.
A sú niekde zazdieľané?
Ako?
Či sú niekde zazdieľané?
Nerozumiem, ako zazdieľané.
Šeruješ ostatné.
Moje zdrojové súbory?
Mhm.
Zatiaľ nie, ale môžem ich tam kľudne dať, ak by ste chceli. Na GitLab alebo GitHub.
Dobre. Tak ďakujeme veľmi, ale ešte.
Lebo to sa vám určite bude v budúcnosti hodiť. Existuje knižnica OpenCV. Ona je implementovaná v C++, ale má nádherné interfejs k Pythonu. U nás boli teraz dvaja diplomanti, ktorí spracúvajú pohyb bielých krviniek. Detekujú a robia z toho normálne vektorové veci a mohli tu byť, lenže nie sú takí odvážni ako vy. Treba takto prísť a povedať prosím, čo ďalej sa uvidí. Takže veľmi by som vám odporúčal tú OpenCV, OpenCV.
Hej, toto poznám.
Tak tešíme sa, že budúci rok tu budeme mať aj zo Žilinskej univerzity doktorantov.
Oni končí.
Tak. Ešte niekto? No?
Je v Pythone alebo v Anaconde aj nejaká alternatíva k Simulingu?
To som nenašla, nie. Neviem. Možno je, ale neviem o nej.
To bohužiaľ nie je, ale možno niekto poznáte ďalší systém z Cila. Neviem, jak sa to číta. Robili to Francúzi, v pozadí je podobne ako v MATLABe tiež Fortran a on má také podobné interfejs ako je Simulink. Neviem, ako je dobre na tom, ale to je jedna možnosť. A ďalšia možnosť, to máte asi pravdu, ale niečo podobné. Ale ďalšia možnosť, jeden kolega u nás vyvinul PSE, to je Python Simulation Editor. To je len začiatok vývoja, ale je to dobré. Takže skúste zagoogliť Python Simulation Editor a nájdete pekne.
Dobre. Ďakujeme teda. Už sme vyčerpali všetky otázky, alebo ešte niekto sa odváži? Dobre. Myslím si, že sme ti dali zabrať, ale cez prestávku kľudne sa môžete hocičo opýtať. Teraz si dáme prestávku, 10 minútovú, začneme opäť 10:20. Ďakujeme. Chcela by som vám pripomenúť, že vaše otázky, ktoré máte, môžete pridávať na slajdu do skupiny PyCon.sk do malého auditoria. Teraz nám svoju prednášku o Mozilla loves Python, alebo Mozilla ľúbi Python, alebo Mozilla srdiečko Python prinesie Michal Vašiček.
Takže já vás zdravím. Děkuji, že jste přišli v neděli v tuhle dobu v tak hojném počtu. Něco málo o mně. Jsem Michal, dobrovolničím v Mozilla.cz, kde pracuji na překladech a stání na stánku, odpovídání na inteligentní dotazy a pomáhám na Mozilla Support. Když tak ještě než začnu, tak včera padlo pár dotazů, jestli budou nějaký trička, jestli je možný získat, tak tu mám tu Mko a Sko, tak za inteligentní dotaz na konci můžu předat. Takže máte motivaci. Bude to neúplně jakože pythonovská přednáška, budeme si povídat spíš o tom, jak se to používá, než o těch detailech a o kódu. Takže z začátku malé shrnutí. Víc než 371 projektů na hlavním GitHubu Mozilla, což je github.com/Mozilla, je v Pythonu. Potom má Mozilla ještě spoustu dalších účtů. Ty projekty jsou roztříštěný i po účtech jednotlivých zaměstnanců, takže jich mnohem víc než 400. Taktéž většina webů Mozilla je psaná v Pythonu, včetně backendu. Vlastně backend webů Mozilla je psán v Pythonu. A ti z vás, kteří používají Firefox nebo Thunderbird, tak se s Pythonem setkávají právě ve Firefoxu nebo Thunderbirdu při aktualizacích, protože o ty se stará taky Python. První projekt, který je relativně zajímavý a mohl by se vám i hodit, je Moz Regression, který vlastně slouží k tomu, aby se našel commit, kde vzniknul bug. Takže když je Nightly Firefox, což je vlastně úplně ta nejzabugovanější a nejčastěji aktualizovaná verze Firefoxu, tak se tam bugy objevují a ztrácí. Takže Moz Regression dělá vlastně to, že když víte, kdy tam ta chyba ještě nebyla a máte jakoby tam tu chybu teď, tak si stačí zadat datum, kdy to fungovalo, datum, kdy to už nefunguje a Moz Regression postupně spouští všechny buildy, ptá se, jestli tady v tom buildu chyba je nebo není a na základě toho určí přesný commit anebo aspoň sadu commitů, kde se ta chyba objevila. K dispozici je i grafické rozhraní, které jsem teda nezkoušel. A neměl by problém ho použít i pro vlastní projekty, mělo by stačit ho trošičku upravit, ale v defaultu podporuje Firefox, Thunderbird, Firefox pro Android a teda ještě Firefox OS, který je mrtvý. Tak další projekt je Observatory, který se bude hodit spíš webařům, protože testuje zabezpečení webu, kontroluje různé HTTP hlavičky, jak jsou na tom certifikáty, jaké prohlížeče podporují, je napojen i na nástroje třetích stran a má takovou trošku tvrdší metodiku, kterou třeba se můžeme podívat, jestli by prošel PyCon.sk. No, tak máme C. Kontroluje vlastně Content Security Policy a tady nějaké bezpečnostní hlavičky, které vlastně řekl bych, že PyCon.sk zrovna nepotřebuje, ale je dobré je mít. Tak, teď je tu Balrog, který, jak už jsem říkal na začátku, tak o aktualizaci se vlastně stará Python. Takže jde právě o Balrog, který běží někde na serverech Mozilla vzadu, potichoučku, pomaloučku a umožňuje vlastně hodně specificky ty aktualizace posílat uživatelům. Když chce Mozilla otestovat nějakou funkci, o které ví, že třeba nefunguje s doplňkem, třeba s adblockem, tak může určit, že tu aktualizaci dostane pouze 10% uživatelů a ti uživatelé nesmí mít nainstalovaný adblock. Případně může určovat i, kolik bitovou verzi musí mít toho produktu, nebo jde určovat i to procento, ke kterému se ta aktualizace dostane. Jde se s tím pohrát. Generuje vlastně XML, které si Firefox Thunderbird stahují a taky by neměl být problém v případě, že byste měli zájem si ho nasadit na na vlastní server. Tak, teď můj oblíbený pontoon, který používáme i my v Mozilla.cz, ve kterém vlastně překládáme. Je to něco jako Transifex nebo Crowdin, což používá většina open source projektů pro překlady. Akorát teda, tak si to vyvíjí přímo Mozilla. Je tam feature quality checks, která je relativně zajímavá a umožňuje vlastně, když mám nějaký zdrojový string a ten zdrojový string má nějaké proměnné nebo nějaké jakoby názvy, které prostě musí zůstat, nějaké zkratky nebo tak, tak když vlastně ten překladatel ten string přeloží, tak a má tam nějaké chyby, třeba v názvu té proměnné nebo v té zkratce, že tam udělal překlep, nebo že mu tam třeba chybí čárka nebo ampersand nebo nějaký podobný znak, nebo třeba, že ta věta má začínat malým písmenem, začíná velkým písmenem, nemá končit tečkou, končí tečkou, tak Pontoon na to všechno upozorní a ten překlad neprojde. Samozřejmě to běží v Djangu a co je na něm další zajímavá věc, tak umí navrhovat překlady od třetích stran. Je tam napojený Bing Translator, který trošku funguje, trošku nefunguje. Potom to umí prohledávat všechny projekty, co má Mozilla v repozitářích a na základě z těch jakoby vytahovat podobné stringy a navrhovat ty překlady. A teďka se třeba uvažuje o tom, že protože ve slovenské komunitě je moc málo lidí, tak se vlastně vytvoří se nástroj, který, protože čeština a slovenština jsou hodně podobné jazyky, tak vezme český string, který my přeložíme a udělá z něj slovenskou verzi, ve které by nemělo být zase tolik překlepů, protože jsou to prostě slovanské jazyky, ve kterých se i stejně skloňuje a podobně. A přeloží ho do slovenštiny a Slováci ho jenom schválí, že je vážně v pořádku. Takže by jim to mělo ušetřit relativně hodně času. Samozřejmě umožňuje Pontoon sledovat výkon jednotlivých překladatelů a nabízí i takovou zajímavou feature, které se říká in-page lokalizace. Já ho tu můžu ukázat. Že vlastně se dají lokalizovat weby, klidně psané v Djangu, přímo ve stránce a je přímo vidět, jestli to někde přetýká nebo prostě nějak nesedí. Jestli třeba blbne font. No, už tu máme otázky. To jsem ještě... Tak a poslední projekt teda, vypadá to, že jsem to sjel hodně rychle. Tak je Sync, Firefox Sync, který vlastně slouží k synchronizaci dat mezi různýma zařízeníma. Podporuje Firefox pro Android, vlastně všechny Firefoxy, které existují. Myslím, že je tam i nějaká podpora Thunderbirdu. Nabízí end-to-end šifrování, takže se ty data šifrují přímo v prohlížeči. A na server nejde ani ten klíč, ani jakoby ta surová data, takže vlastně Mozilla vůbec neví, o čem to je. Na Installfestu, který byl před týdnem v Praze, tak měl Tomáš Zelina, co stojí teďka na stánku před workshop nasazování Firefox Syncu, takže kdybyste měli zájem nedávat svoje data Mozilla a mít vlastní Firefox Sync nahozený na vlastním serveru, tak měl by být někde k dispozici záznam. Prý to není těžký nasadit. Autorizuje se pomocí Browser ID, což je zajímavá feature, která vlastně vytvoří nějakou cookie, která je sdílená mezi stránkama a na základě téhle cookie tak se zjišťuje identita toho uživatele. Takže může to teoreticky sloužit ke sledování, ale když má Mozilla třeba víc služeb, tak se vlastně stačí přihlásit na jednu a je to přihlášené na všechny, stejně jako to má třeba Google. Tak a já jsem to vážně sjel relativně rychle, takže tu mám výzvu k zapojení se. Protože Mozilla dělá všechno open source, je to vlastně její cíl dělat úplně všechno open source. Teď například koupila Pocket, jestli znáte, je to doplněk pro prohlížeče, který slouží k tomu si ukládat stránky na později. Není sice psaný v Pythonu, ale hodlá ho otevřít po tom, co ho koupila za celkem velké peníze a bude open source, takže taky si ho budete moct nahodit na vlastní server. A protože je Mozilla open source a vlastně všechno spadá pod Mozilla Foundation, což je nadace, tak tam hrajou určitou roli peníze a snaží se minimalizovat náklady, takže se hodně jede na dobrovolnících. My překlady děláme dobrovolně, podporu uživatelů děláme dobrovolně a i velká část vývojářů je dobrovolná, takže vznikla taková zajímavá webová stránka What can I do for Mozilla. Jestli chcete, tak se můžete podívat. A dá se tady vlastně proklikat k tomu, co by vás třeba mohlo bavit a v čem byste nám mohli pomoct. Když se tu proklikám jak writing code. A jo, Python jsem zase překlik. Jo, tak se tu dá vybrat, že chcete dělat Firefox test engineering, release engineering. Hodně kódu Firefoxu je generováno Pythonými skripty, což je vlastně ještě jedna věc. Firefox, Thunderbird a vlastně všechny tady tyhle hlavní produkty Mozily, které jsou jakože takové ty větší, tak jsou builděny Pythonem. Jo. Všechno se dělá automaticky pomocí Pythonu. Takže můžete se proklikat i třeba k tomu web developmentu. Takže pokud umíte Django, tak můžete pomoct třeba s Pontoonem nebo s webovkama Mozilla.org. A teda děkuju. Pokud jsou teda nějaké inteligentní dotazy, tak budu rád, pokud jich bude hodně.
Tu máme dve otázky. Prvá otázka je, že aký typ šifrovania je implementovaný v prehľadači?
Pokud myslí, co se týče toho Firefox Syncu, tak tam si nejsem úplně jistý, protože Firefox Sync upřímně nepoužívám. Ale mám dojem, že je to AS 256.
Ako hodnotíš tuto otázku?
Jak jako hodnotím?
A ďalšie je, aká je motivácia pre tvoju prácu?
Tak mě to baví. Upřímně jako je prostě jako hře to u srdíčka, když můžu někomu třeba odpovědět na nějakou otázku na support Mozilla, nebo prostě jako upřímně mě to i třeba hodně zlepšilo v angličtině ty překlady. Nebo vím, že jsem se dostal do Pythonu právě díky Pontoonu, do kterého jsem se snažil přispívat, když jsem Python jako, to byla španělská vesnice pro mě. Takže jako určitě mi to i pomáhá, co se jako toho IT života týče.
Je tu ešte nejaká otázka z publika? Áno?
Pracovisko nemáme, nejbližší kancelář je v Berlíně, takže i zaměstnanci pracují remote z Česka. Ale čas od času míváme různé hackathony, workshopy a takhle. Takže tam se jakože sejdeme a prostě pracujeme tam spolu, ale že bychom měli nějaké konkrétní místo, to ne.
Ešte nejaké?
Ještě je tu jedno tričko, protože přes internet trička posílat nemůžu.
Možno ten, kto sa opýtal tú otázku, sedí tu v miestnosti a volá sa Anonymous. Niekto taký? Tak máme dve trička?
Máme 2 trička, no.
Tak tam sa hlásí.
Ano, prosím.
Že ona podala tú otázku.
A jo, vy jste podala tu otázku, super. Tak už trička už nejsou.
Dobre. Tak ďakujeme, pokiaľ nie sú ďalšie otázky, ďakujeme Michalovi Vašičkovi za jeho prezentáciu.
Tak kdyby vás ještě něco napadlo, tak jsme tady na stánku až do večera. Takže můžete se zeptat tam.
Ďakujeme veľmi pekne. Teraz máme takú dlhšiu prestávku až do 11.
že či tu je niekto, kto nerozumie po slovensky.
Tak, dobrý deň. Opäť vás vítam po takej dlhšej prestávke. Dúfam, že ste načerpali síl. A opäť by som sa rada opýtala tú istú otázku ako pred prestávkou. Is anybody here who can't speak Slovak or Czech? No. Only one? Two? Okay. So we can vote if you would like to have this presentation in English or in Czech, in Slovak language. Sorry.
Ale viem aj po česky, ak treba.
Also Czech, if you would
Som
like.
pol na pol.
Okay, so let's vote. Who is for English? Okay, 1, 2, 3. Okay, it's in English.
It's in English, okay.
Okay? Fine. Democracy. Okay, so
Okay.
this is Tibor Zavadil, and he will tell you more about sentiment analysis of customer comments.
Okay, hello. Thank you for coming to my presentation, and thank you for the organizers for inviting me. I was looking forward to giving presentation finally in Slovak because at my work I have to speak English all the time. But you voted for English, so it's my bad luck. I will give it in English. It will be about sentiment analysis of our customer comments. So let me briefly show you what I will be talking about. I will make a short introduction about me, the company, and the project. Then I will show how to do sentiment analysis and show you some demo. And then I will present results and challenges. So about me, I would call myself as a curious and an courageous adventurer. So I like new excitements and I like adrenaline sports, as you can see on the bottom line. I studied a lot abroad. I have some masters and PhD. I started with mathematics and then I moved through statistics and econometrics to economics. So I cover also social sciences. I did postdoc in Paris and then I moved back to Slovakia. I worked for 5 years for the central bank of Slovakia. And then I was headhunted by a Swiss insurance company to work for them as a data scientist. And I have crazy hobbies like skydiving, scuba diving, skiing, hunting and yoga, or even I like swimming in cold water. So the company, I work for Zurich Insurance, which is one of the biggest global groups in the world. They have they have companies all over the world. The dark blue is where we are present, and light blue is where we have some intermediary. And gray ones are where we are leaving the market, and white is where we are not present, but there are very few countries. So we cover almost 210 countries. It's a very old insurance company. It was founded more than 150 years ago. Employs 54,000 people. And last year was a very successful year. We had a $4.5 billion business operating profit. So we are expecting pretty good bonuses this year. The project I'm working on is related to so-called transactional net promoter system. It's a system that collects customer feedback. So we want to know how our customers are happy with our services. So after each event, we ask our customers, how did it go when our customers change the policy by additional policy or have an accident and have to handle claim. We ask them how they were satisfied, and they rate us from 0 to 10 because we ask them how likely would you recommend our company to your friends or relatives. So 0 means absolutely no chance, 10 means 100% sure, and then we measure so-called net promoter score, which is a difference between proportion of promoters, those that gave us the high score, detracted by the proportion of detractors, those guys that are not happy. And this is a very important score. Our managers have it as a KPI, key performance indicator. They really want to keep the level of customer satisfaction pretty high. And I entered this project because I'm focusing or specializing at this time in text mining. So last year I spent a lot by studying various text mining techniques. And because this system collects lots of text data, I was asked to analyze them, to automate the analysis of this data, and to be able to detect problems in the comments and propose corrective actions. So if we see that some customers struggle with connecting to call center, we know that we have problems on the phone line, there are not enough people, whatever, so we can propose corrective actions and keep our customers happy. And it's very important because what we observe is that happy customers stay longer with our company and buy more products. So we collect more gross written premium from these customers. Therefore, keeping customers happy is very important for our business, and I think for any business. So what's the goal of my presentation? It is to identify satisfaction of our customers with with the service that we provide based on their comments. And I must say that I'm going to show you only text data without the score, because I got data from UK and they don't have any score 0 to 10. So I just have raw text data and I don't know whether the customer is happy or unhappy in advance. I have to detect it from this comment. And I'm going to use so-called supervised machine learning because I have labeled data, labeled by a human, by some colleagues from UK. So I know the sentiment of these comments, and I'm trying to build a model, classification model that can predict sentiment on new data. And I'm going to use natural language processing methods, some vectorization, so-called bag-overs representation, and then I play with selection of suitable classifiers, parameters, and features. Are you familiar with text analytics bag-overs representation? There were some presentation about it. So it's basically I'm creating a word occurrence matrix on the lines. I have documents or comments, and columns are specific words, and then I just record whether the word occurs in the comment or not. So it's a 0-1 matrix, or I can even record number of occurrences. And this matrix is very wide and quite sparse. There are many zeros. So I use these occurrences as explanatory variables in my prediction model. So as I mentioned, I have data from UK labeled by humans, so I know the sentiment from this data. And I'm going to perform this analysis in Python using open source libraries, namely NLTK, which is Natural Language Toolkit. It was developed by 3 universities, professors from 3 universities, I guess US, Australia, and Great Britain. And then I use scikit-learn to select proper classifier and do the sentiment analysis classification, sentiment classification. Now I will go to demo, so let me switch. First I will show you the data, but only very briefly because these data are confidential, so I cannot show you too much of this data. As you can see, one column contains comments and the other sentiment. So some comments are long, some are short, some are middle size. This is the positive comment we got, so you can see that the person is very happy with our stuff. Everything went fine. Some people are unhappy. I don't know, this guy says that he got courtesy car. His car was repaired after the accident, but he still did not get any letter from us telling him that the claim is settled down. So probably he's happy with the service, but he was expecting some letter he did not get. So there are also some ambiguities that we did well, but we forgot to send letter. But at the end, I have just quite a short sample. I can use this, yes, okay, because this has only 317 observations. So this is a proof of concept that I finished recently, and I'm expecting now a big data set and build a model that will be implemented in the production. So these are the data I will use for the analysis, and I will show you the code that I wrote. So it's not too long. I will run it. I already ran it once, but I will run it one more time to show you that it really works well. So as you can see, I use some packages. This open PyExcel is for opening, reading data from Excel sheet. Then I use some libraries from scikit-learn, like metrics, splitting sample into train sample and test sample. Then some packages for feature selection and pipeline. And natural language toolkit I use mainly for to extract or remove stop words from the comments, and then tokenize sentences, use some stemming and lemmatization. Are you familiar with natural language processing, what it means? So basically what you need to do when you have a raw text, you have to remove some punctuation, non-alphanumeric characters. Then you usually put it to lowercase. You split sentences into words. Then you extract the stem from the words, or lemmas. Stem is just the basic root of the word, while lemma is the basic form. So just to give you an example, I run. Oh, sorry, I have a T-shirt that it's for my kids. I run, and the basic form is run. He runs. I can remove s. I get basic form run. So stemmer can do it automatically. But when I use past tense, I ran, stemmer will keep the word ran. It's not able to detect that ran is past tense of run. For this, I need lemmatization to look up this word in a dictionary and find that the basic form of ran is run. So lemmatization is more precise, but it takes much more time than stemming, because stemming is automatic removal of the suffix, while lemmatization, you have to look up each word in a dictionary. So I tried both, and I figured out that lemmatization indeed provided better results, even though it took much more time. So here I do some initialization. I define stop words. Then I have a function that can do part of speech tagging, so syntactic analysis to determine which word is noun, adjective, adverb, verb, etc. This is important for lemmatization, to find out whether, for example, the word meeting is a noun or a verb. I'm meeting my friend, or I'm meeting my friend at a meeting. So these meeting are has two different meanings. And then I load the data. As you can see, now I can show you the results. Where did I start it? Here. So I load 317 observations, and I do NLP processing here. So how do I do it? I put data to lowercase, then I remove punctuation using the package re, and here I do NLP of comments. So first I use tokenizer to split comments into words. Then I remove stop words from these words. So what are stop words? These are very common words that have no meaning for the analysis, like I, am, he, is, of, the, and, etc. So these stop words, they just increase dimensionality of the problem, but these words really have no added value. So it's really good to remove them. When I try to run this analysis with stop words, I had problems to converge. So these stop words, it's a mess you don't want to have in your model. So it's important to remove stop words. Then I used lemmatization, so part of speech tagging, and then lemma, and then I just save the comments to matrix A, and I go to classification. Here I split the set sample into training set and testing set. Why do I do this? Because you cannot, it's a stupid thing to do, to build a model on one data and test it on the same data. What you want to do, you want to get a robust model that can predict labels for unseen data. So when you split sample into test data and train data, you build model on train data, but you test the model on test data, and these test data are new to the model. So this guarantees that your model is robust and works well on unseen data. So I use a proportion for 60 to 40. So 60% is my train sample and 40% test sample. There is a command in Python to do that. And here I use all kinds of classifiers that I found in scikit-learn. I really try all of them. If you see any I did not, which is not on my list, just let me know, but I really try all of them. All of them that can work with sparse matrices. There are a couple of them that require dense matrices, but I did not use them because when you analyze text, you work with sparse matrices, like word occurrence matrix is sparse. There are many zeros. So I try AdaBoost, logistic regression, and then an A-base, nearest neighbors, neural nets, calibration methods, support vector machine, or even decision trees. And here I run the classifier, and I print the result, and here are the results. So you can see that some classifiers can split the trained sample perfectly. Like this is the precision, accuracy. With 100% accuracy, they can split trained sample into positive and negative sentiment, but they don't do so well in a test sample. So this is what I said. I could, if I use the same data to build my model and test my model, I could say, wow, my model is perfect, 100% accuracy. But it's important to test it on a new data from test sample. And here I achieve accuracy of 80%. And then I also use 5-fold cross-validation. Cross-validation is that I split sample into 5 equal parts, and I use 1 as a test sample and 4 remaining parts as a trained sample. So I build a model and predict labels for this one part. And then I use another part as a test sample and predict based on the other 4 parts, etc. So, then I see which accuracy I achieve. So basically cross-validation is how the sample can predict itself, but always using remaining parts to predict, build a model and predict one part that is a test sample. It's important, my sample is quite small, and I think cross-validation is the best measure I should use. So when I compare all these classifiers, I can see that the best one is nearest centroid. And this is something that surprised me, because usually when you want to classify, when you use text data for classification, usually the best classifier is linear support vector machine classifier. This is like rule of thumb that you should usually use this one. But as we can see, it does not perform as good as nearest centroid. Nearest centroid classifier is very simple. Are you familiar with it, or I can briefly explain? When you have some points in a 2-dimensional space and you want to create a classifier, so you take the central point of one group, central point of the other group, like central point means the average of all coordinates, and then you draw the line between the two, and when the new observation falls, in which half, that class you attribute. So it's very, very simple. It does not have to remember all the observations. It's much simpler than k nearest neighbor. And surprisingly, it works the best in my case. So I'm trying to further improve it. And here I'm using so-called grid search for the parameters. There is, however, one problem that nearest centroid does not really have any parameters, because it's a purely non-parametric model. So what I'm playing with, I'm just trying to use different measures, not Euclidean, but Manhattan, that takes absolute values between the differences in coordinates. Or I try to play with a range of n-gram, whether to use unique words, unigram, only one word, or also combination of 2 neighboring words. And then stop words I already used. And also I'm trying to determine whether it's enough to record only occurrence of the word, like 0, 1, whether it occurs or not, or number of occurrences. So if the word occurs 3 times, I will have 3 in the occurrence matrix, not only 1. And then using inverse document, frequency, weights, or different norms. And I'm combining all these different settings and trying to find out whether my classifier improves, whether I get better result. And as you can see, here are the optimal values. So it's really best to use Euclidean measure use binary representation, only unigrams are enough, L2 norm is good. It's good to use English stop words and also weights. But my performance does not increase too much. The only improvement I get compared to the previous one is in cross-validation accuracy. I get slight improvement, 86.4%, and now I have 86.8%. So this is because, as I mentioned, the central nearest centroid has no parameters. But if I use, for example, support vector meshing classifier by finding the best combination of parameters, I can significantly improve the performance of the classifier. So this is important to do, even though in my case it was not very important, because this nearest centroid classifier does not have any parameters, as I already said. So what I tried next to further improve the accuracy, I was trying to search for best features. So what are the features? Features are the columns. You have these metrics with each word and its occurrences, and not each word is important to be present in the model. Some words are more deterministic about the sentiment, some are absolutely independent of the sentiment. So I use two methods to search for best features. The first one is select percentile. So I select top X percentile of features that are the most correlated with the outcome. So I look at the occurrence of the word, how it is correlated with the class, positive or negative sentiment. And then I record this correlation, and I sort it and take only the top. Here I use 15%, top 15. And I see that my performance improved a little bit. Now I have 87% accuracy in cross-validation. But then I found out that using chi-square test of independence and selecting k best features gives me much better model. So chi-square test of independence measures how independent are features from the outcome. And if I see that some occurrences of words are independent on the outcome, they are not worth to be included in the model. So I focus only on those features that are the most discriminative for the prediction of my sentiment. And I use the first 300 features. I don't remember now how many features I have, but it will be a couple of thousands, because there are a couple of thousands unique words in the data. And I observed that my precision jumped to 88%, which is pretty good precision. So then I'm doing finally cross-validation to see how this precision, how high it is in each part of the sample when I cut it in 5 equal parts. And I see that there are some differences. In some parts, the model predicts very well, like 95%. In some parts, only 80%. So the mean accuracy is estimated with quite a high standard error. Therefore, I do also threefold validation, because my sample is very small, so I have only 300 observations. So cutting sample in 5 parts, you are left with 60 observations in 1 part, which is quite few to build a robust model. When I use threefold cross-validation, I get very similar accuracy, so this is fine. And then I also calculate accuracy, precision, recall, and F-score. I'm not sure whether you are familiar with these terms. Like accuracy is how precisely I can predict both positive and negative sentiment, while precision is how accurately I can predict negative sentiment. We are mainly interested in negative comments, because we want to detect unhappy customers. If customer is happy, fine, we are doing good job. But if a customer is unhappy, we need to know why. So for us, it's important to detect negative sentiment. and I can do it with a precision of around 90%. And the recall is from those that express negative sentiment, how many can we detect by our model? And you can see that almost 95% can be detected by the model, and F-score is a weighted average between precision and recall. So this is the end of my demo, and now I will just summarize the results. So I achieved quite a high accuracy in precision or prediction of sentiment, mainly because I use advanced natural language processing, lemmatization, have developed to decrease the dimensionality of the problem, to match similar words together or the same word in different forms together. Then I experimented with various classifiers to really see which one works the best. Each data require different approach, different classifier. Then I used parametric research, but it did not improve much my precision because nearest centroid has no parameters. And feature selection helped me to improve further my precision. So it's important to do all three of these. So my best model has accuracy around 90%, as I already mentioned. And now I want to mention some challenges. So when you do sentiment analysis, you have problems with typos or abbreviations. So we have problem to match words with real words. Then some people use jargon, slang, dialect, or vulgarisms. So they use specific words that do not necessarily exist in vocabulary. Then synonyms, collocations, or idioms use different words with different meanings. Then you have problems with name entities, how to distinguish Apple, that is over there, the computer, company producing computers, with a fruit. Then irony, sarcasm is very difficult because we humans sometimes have problems to understand sarcasm and not computers. Then we have some problem with negation and intensification. If I say it was not terribly bad, is it positive or negative? It is probably positive, but I use three negative words to express something positive. So computer is quite confused with such sentences. And then many people on social media use emoticons or symbols that are ignored after NLP. So if you want to make better model, you should take them into account. And there are also, of course, also different various culture differences, like Americans say awesome, but they give a low score to a film, and I don't know, Swedish people say it was nothing special, but they give a full score because they express emotions in a different way. Yeah, 2 minutes. So the last slide. Thank you for your attention, and we are hiring IT specialists and data analysts. Let me know if you are interested. That's my email. Thank you very much for your attention. I'm ready for questions.
Can you answer the questions there? Okay. So we have many questions here, but some of them have been already answered in your part with challenges. But here's one question. Can you tell us how big is the production dataset?
Production data set. So we collect this data in each country. So 200 countries collect feedback from our customers. Each country has several thousands or hundreds of thousands clients, so this data set is huge. As far as I know from UK, we collect a couple of thousands comments each month. And over past years, the data set can be pretty huge. I don't know the exact number, but lots of comments in different various languages. So this is also a challenge that after processing this English data, I will start with Spanish data, French data, German data, and I have to build my model that will be language independent.
So you answered two questions, because the next question was, do you only analyze comments in a single language, English?
No. So to analyze the comments in other language, I have to have a list of stop words in the language. I want to analyze, for example, in German, there are also stop words like du, bist, ich bin, in. derdidas, whatever, this will be stop words that must be removed. And then you have to have also stammer, a good stammer, to extract the root of the word, because suffixes are different in each language. So you have to have good stammer or lemmatizer, and also a list of stop words in the language to be able to process data in this language.
Another question. What is the biggest difference between programming in Slovakia and programming in Switzerland?
I never worked in Switzerland, so I can't answer this question. But I lived a lot abroad, and I returned just a couple of years ago to Slovakia. And I must say that we are doing pretty well here in Slovakia. I have no more motivation to move out. I'm happy here. So I think many things changed, and you can find very good job even here at home. You don't need to travel abroad to have a good job.
The last question. Do you use neural network for sentiment classification too?
Not yet, but I'd like to. I know that there are some new techniques in deep learning, how to extract not only some classes or sentiment from text, but also semantics, the meaning of words. And there are quite complicated approaches using deep learning and neural nets. So I'm now learning these new approaches, but I'm not using them so far.
So, thank you very much again. You can ask him anything during the break. Now we have a break for 9 minutes. So thank you, Tibor, again.
Thank you very much. Bye.
So, is it okay to start now? Yeah. So, this is the last presentation today, which will be held in Slovak language. So, who can't speak Slovak? You can learn something in Slovak language,
Or we can,
but I'm not sure if you
or we can speak in English. That's not a problem.
in English. So, is it okay for you?
Yeah, no
Yeah?
problem.
Okay, so another voting. Who is for English? Okay, 1, 2, 3, 4. And for Slovak language? 1. So, okay, so you can start in Slovak language. And then
No,
we're gonna-
I'll
will
do it in
be
English. I'll do it in English if it's not a problem.
Yeah. Okay, so let me introduce Peter Fedoročko, and he will speak in English, and he will tell you more about the machine search for meaning. Thank you.
Thanks.
Yes, sir.
Hi everyone. So I hope you don't mind English here. Let's start with a small poll. Who's using Python more for data analytics than programming? And who's using Python more for programming than data analytics? Okay, I hope I will not bore you the second group, because I'll be speaking more about the data analytics here. So I'm Peter. I'm living 10 years in Prague, where I work as a business analyst and data analyst and programmer. 2 years ago, I co-founded a company called Stories. Stories is a software for a business which tries to help them understand what's going on in their company and what's causing this. So this is the reason of the presentation, which I call the machine search for meaning, because we are really building the analytics or a search engine, which is searching a huge amount of a company's data and trying to explain everything for them. So I'm not sure if you noticed, but the last year, every time I open the TechCrunch, Twitter, or LinkedIn, everywhere I see like how AI is going to revolutionize the world, and how people will lose jobs because there will be robots. But then I look in my office and I saw 15 of my colleagues, right, in a company, and basically what we have been doing was we were sitting there, and there were our colleagues, our managers, or our customers coming to us and showing us the Excels and saying, hey, can you figure out why this number is red? So we fired up our machines, we opened our Tableaus and R's and Jupyter notebooks and crunched data for a week. And then we came with a presentation and they say, we don't care about this number anymore, we have another problem right now. So I was really frustrated because I saw a lot of clever people sitting in the room, and we spent 80% of our time just crunching the numbers, and 95% of time it was meaningless, right? I'm a lazy person from the nature, so I said, hey, there needs to be a way how I can automatize this 80% of my tedious work and spend my time more effectively explaining data to my colleagues or to my managers or to my clients, right? So we have been thinking last 2 years with my co-founders and with my team, how to figure it out. And we spent 1 year by building the pilot of the companies or the search engine we called Stories. And then last year and last summer, we actually got a seed funding of around 15 million Czech crowns, $600,000 or euros, to bring this to the market. So in the last 7 months, we have been working as a company. We have 5 clients right now and around 15 pilot projects. So what's the Stories? So we are trying, after 30 years of business using the Excel, we are trying to figure out something better, right? We are trying to explain and everyone in the company, for each person, create a personalized dashboard saying, these are the top priorities you have to focus on today based on the data, and this is the reason why is this happening, right? So we have the analytics and the reporting part, which is saying, what's important for you that particular day, right? Why is this happening, and who's responsible? So who should take some action? And of course, then once we figure out this, we don't want to be as a normal reporting tool. So the people then, they bring up their phones or they go to another office and they start discussing it. But we want to keep that people in our application, right? And let them collaborate there. So we can collect more data about the decision they made and the actions they took, so we can have more data to learn from and suggest them a better solution in the future, right? So this is stories. The right part is very interesting too, but it's more about the business and UX. The left part is more about the Python and data analytics, so I'll focus more on the left part today. If you still cannot imagine what it is, I sometimes try to make it very simple and say it's like Excel plus Slack, right? So in Excel, you finish with a cell. You see the number in the cell. In our application and stories, it starts with a cell. So you see the number, but each number is a story, which has some updates, which has some notifications, which has some explanation inside, right? So just a few simple slides, how it looked like. We started with this, which is the list of 10 priorities when the user opens the applications. These are the top stories in your business, which you should really focus on. But the lesson learned was it's a huge mind shift for people, right? So they didn't understand the list. So this is a nice user experience, maybe issue. So we figure out, oh, we have to bring them something which looks more like an Excel. So we actually changed our application a little bit. It looks more like an Excel. They are very satisfied, but they still have the advantages. They have a notification, what's important, where you should focus, and what you should not care about this week or today, right? And then if you click on the cell, you have notifications, you have updates, or you can see the whole stories, right? Where you can collaborate, where you see the explanation. This is the bottom part, where you see the textual description of what's going on. You have your colleagues, which you can invite, and you can collaborate, right? And then we use the data to learn which actions actually lead to some improvement and which was basically useless, right? So this is the end of the product description. Let's go to the programming. Actually, everyone in the co-founding team and all our first employees, no one of us was a programmer, right? So we started like a data analyst and business analyst guy who can work with the ETL tools, who can script in R and do a little bit Python, but we never thought we will actually build something in Python. We say, oh, let's use the tools we know, to build this. But we very quickly figure out it's impossible, right? Because we need to do a lot of custom things, which, these ETL tools or R is not sufficient. So I have been looking for a tool I can use and which can bring me all the benefits, right? So I can do some generic programming inside, I can do some data analytics, I can Okay, we can continue right now. So this is everything. We use Python this day for. I can speak about every of this point a lot, but I just decided I will pick a few things today, and I try to describe you how we think about the problem, what are kind of the problems we have to solve, and why we actually did the company, right? So the two things are data analytics and pandas. So how we use pandas to do the analytics on a huge number of data, and how we leverage graph databases, namely Network X. And then if we have some remaining time, we can speak a little bit about how we scale it. Because we were a data analyst, so we wrote a very not optimal solution at the beginning, and then we had to, scale it, which is little difficult for non-programmers. So when you want to architect something like this as a system which takes the data and converts it into the stories, we said the best architecture would be if we design it the same way as the data analyst thinks, right? So I take a data or a report, I take a look at it, I analyze it, then I evaluate it, then I find the explanations, then I present it to someone, right? So there's a number of steps you have to take to go from the raw data to the stories. And we took the same approach with the with our own application. So we basically build the data pipeline or the workflow which suits us best. So the first problem is I need to figure out what's the most important in the company, right? But usually the businesses we serve, they are very stable, right? They are large businesses. And on the aggregated level, somewhere on the top, right, their performance is stable, or it's slowly growing or slowly declining. But nothing interesting is going on there. What's interesting is what's going on inside when you look deeper into the data, right? But I, as a data analyst, can do, let's say, 30 analysis per hour, right? But the large companies we saw, they had like 300,000 signals per day, right? So they have a lot of combinations how you can look at the data. And we didn't want to miss it. So we say, let's do the brute force. Let's generate every possible combination, every possible report or view. I can take a look at it, then analyze it, and then figure out if something important is going there or not, right? So we took some ITER tools and collections, and we really generate the metadata for every possible view or report, let's say, which can be generated from the data. Of course, there are some rules and there are some exceptions, which is out of the scope of today's presentation, but at the end, you get a list of all the possible combinations of the data you're able to analyze. So the second problem is how to analyze it, right? I have a 300,000 views which I need to analyze. If I'm non-human, I will just take some analyst, I will open their eyes and I will say, so I will be flashing in front of your eyes a lot of reports and you will be telling me if there's something going on or not, but that's not very human. So we said, let's leverage pandas and let's run every report through some standard analysis. And over the time, we figure out there is around 10 or 12 possible scenarios which can happen in a time series data, right? I didn't put a names in these charts because I consider this to be a lot of internal know-how of our company. But basically, this is a few examples of what can happen with the data. And we wrote, for each of the situation, we wrote our own dedicated pattern, as we call it, right? Which identifies if this situation is going on in the data or it's not happening in the data, right? And there was another problem because I have a lot of colleagues who came from, from our background, or they were used to analyze data the way that they saw the view or they saw the input data, and they know there's a number of rows and there's a number of columns and there is a seasonality in this data, and this is the sparsity of the data. But in our case, you don't know what kind of data you get because you get one of 300,000 slices, right? So it can be this sparsity, it can have one row, it can have 15 rows, it can have one column, it can have 20 columns, right? So this was a huge mind shift for us to figure out how we should write this analysis and pandas to be able to adjust to any possible data you can get, right? But eventually, you have library of 12 patterns, which you apply to all 300,000 slices, and basically they make the decision if there's something going on in the data, if one of the patterns was identified or not, right? So basically, they're just doing the separation. Nothing going on, nothing interesting going on here, nothing interesting going on here. Oh, there's something interesting going on here, right? The green one. So I'll mark it as a story, and then I can work with it further. So it took us around half a year to build it, right? And then we were satisfied with the results. That it actually showed us, there are cells declining somewhere, let's say in Košice, right? So there are cells declining in Košice, and we were very satisfied with the results because we saw, we have an engine which can identify if something interesting is going on in data. But we ran it. We took a look at our stories in a list like this, and then we were shocked, like, oops. But it seems that it also identified that cells are declining in Prešov and in Žilina and in Bratislava and actually in whole Slovakia, right? So there were a lot of very similar stories. And then we figure out, actually, each signal, it's not a separated item in the company, right? But they are connected somehow to each other, right? So the cost is negatively influenced by the margin, or the Košice is actually the hierarchical child of Slovakia, and so on and so on. So there are connections between all the signals, right? So we have been thinking out how we should put all these separate stories together to figure out where's actually the root cause, of this problem. And we can try a lot of different things, right? We try to iterate over all the stories and find a solution, but it was very time consuming. And then we figure out, oh, it is actually a graph, right? So I can build the graph of all the stories, and then I can evaluate that graph to figure out where's the root, right? So I take a look at sales in Slovakia, and then I say, give me all the children, and it returns me all the children very quickly, right? And then I see, then I can ask the question, are all the children behaving similar to the parent? If yes, I know that the root cause is a parent. If not, then I know that the root cause is somewhere between the children, right? And I found the NetworkX library, which I think is great, and it saved us a lot of time, right? Because we basically very quickly build the graph of the whole company, and then we can just run the query against that graph, like I mentioned before, right? At one moment in time, our designer sit down with one of our analysts, and they actually put together this. This is the graph of the real company, you know, how it looks like. So all the stories linked together, and then we just run the queries against that graph. You can use it to figure out the explanations and finding the root causes. You can also use it for another interesting things, like when you figure out that the organization structure of the company is actually also the graph, and you merge these two graphs together, you can figure out who should be responsible for each of that stories, right? But again, this is also probably out of scope of today's presentation. So this was the third component we put into this data pipeline, and there is more and more components, which unfortunately I cannot mention today because that's a lot of them. But then we run it through the NLTK to generate the text description of the story, and we parse the expressions using PyParsing and so on. We add charts, and at the end, what the user see at the beginning in the application is something like this, right? So this is the story, but there is no human input into this, right? Everything is generated by the machine, right? So the description, the chart, all the markers in the graph, all the explanations, this is automatically generated by the machine. So right now I saved 80% of my time, and I can go and I can be very effective with this one, because I can just go to my customers or to my managers and my clients or colleagues who are in sales and start working with them on the stories. But I don't do any manual work with analyzing and pre-processing the data. What was interesting was I developed this on my Lenovo T400 laptop as a data analyst used to, right? So I had a 20 megabyte sample. We built it for 1 year, and then we wanted to test it on our first customer, right? So I told my colleague to spin up some AWS machines and run the larger data around 300 megabytes or 400 megabytes, which was the last 2 years of their sales, somehow aggregated, right? And we waited all night, and in the morning I had a Slack message saying, oh, it ran for 21 hours, and 16 hours it was just saving data into the database, and it's somewhere in the middle generated 2 gigabytes of metadata, right? So it wasn't very optimal. We figure out, oh, we have another issues. We have to behave more like programmers. We have to start thinking about the effectiveness of the code we are using, right? Because we didn't care that a NumPy and a scikit-learn, they both have a regression function, but one is 0.3 seconds faster. But when you apply that on a 300,000 slices, there's a lot of time you can actually save. Or you should be more, you should think more about the memory. Because if you have one story which saves 100 kilobytes of data, it's okay. But if you have 300,000 stories, that's a lot of things you have to keep in the memory. Another problem was this is in Slovak, but when I searched yesterday in our Slack, the word spadlo, which is like declined or the machine failed, I found 49 results, right? So we had a lot of issues that the data pipeline was too long. We run it as a one script, and when someone made a mistake or they didn't assume that the view will actually look like this and it failed, we lose 10 hours of a processing time. And if you multiply it by 50, which is probably the number of time this occurred, that's a lot of wasted time. So we have to start thinking about how we should scale it, how we can run this in parallel, how we can make it more fault tolerant, how we can write it more optimal. And basically, we had a few approaches we wanted to try. So, in the first thing which came to your mind, if you run the startup, is, oh, I should develop something on my own, right? So I should write my own monitoring solution. I'll just build a new API. I put some salary workers together. I'll put a small front end on top of it, and I'll have everything. I have a nice cockpit. How this can look like and how this can work. It's not very effective for a startup. We spent probably 3 or 4 months building this, and we never ended. So we decided we will have to try something else. We have been using a lot of AWS machines. So some consultants from AWS, they actually called us to Prague, and they said, oh, we want to give you a visit and we want to provide you some free consultancy, right? So how you should do it properly. So they came to us, we explained them what kind of problems we have, and they said, oh, there's a new service called, serverless computing, AWS Lambda. You should just put your patterns and all your functions into Lambda. You will just send the request and they will respond to you if this is a story or not. So we said, oh, this looks pretty nice. We should definitely try it. So they came on Monday, they started helping us developing this, and their first question was, so what are the variables in the pattern? And we say, okay, so there's a small configuration JSON, and then there is a JSON with the metadata describing the slice you have to generate, and then the third variable is data. And they said, oh, data, so this is not very good for Lambda because Lambda doesn't have any internal storage, so you have to send all the data along the HTTP request to the Lambda, right, so it can produce some results and respond. So this is not very effective if you have to do it 300,000 times. Right? So we very quickly figure out, okay, Lambda is not for heavy data analytics tasks. It has some advantages when you want to process the HTTP request or you want to do some API call, but not for data analytics. So they suggested, okay, so we said this is also not a good way to go. So they suggested another solution, which is AWS data pipeline. It seems very promising at the beginning because you can build your own data pipelines inside the AWS infrastructure. So you have the integration with S3 and everything. You have your own images, which you build in AWS available. So it seems very promising. And we figure out we can solve a lot of issues there. Like we can save results after each step. So if something fails, we can just respin the machines and start where it failed, or when we are developing a new component, which is 13 in the row, we don't have to run 12 components, but we can save the data after 12 component and then just reiterate on the 13th component. But the problem with the data pipeline was actually, first, the AWS is not very heavily investing in this particular product, right? So it lacks a really nice and effective user interface for monitoring. You can run only a limited number of instances at the moment, so you cannot really do any parallelization, right? Because they limit you to only 10 or 12 machines, running in a parallel, and so on and so on. So we figured out, okay, this is probably a nice temporary solution, but it's still running very long time because we cannot do our own parallelization. We don't have a very effective monitoring, so our consultants, they cannot, they don't know what's going on actually with the data. And then someone came with a proposal to use the Airflow, which I'm not sure who of you knows Airflow, Apache Airflow right now. Okay, few people. So it's a really nice, this is a really nice open source solution, a platform, originally I think from Airbnb, which is for programmatically, defining, scheduling, and executing workflows, right? So any workflow, but for me, it's a really nice data pipeline workflow. So what you can actually do is write a script which defines every component programmatically, and then you can execute it in the platform, right? So this is the example of the function that actually generates all of our components dynamically, right? And then it looks something like this, right? So I define everything in my code, and eventually I get a subdoc. Doc is a directed acyclic graph, right? So this is how they describe the pipeline, and I get the pipeline, which with every component we have, you can see the parallelization in the middle because there are some operations we can parallelize. These are the pandas patterns which can run in parallel, and then they are put together back before they are inserted into the graph because you cannot parallelize the graph, right? you have to have only one graph to find out the explanations, right? So it's a really nice solution. You can schedule these pipelines, you can monitor these pipelines because you see, what's going on, where's the problem. It has a very good logging, solution. So this is the solution we are using right now for running all of our data pipelines for 15 clients, and it's really nice. So I'm thinking if I have anything else there. Probably not. So if you have any questions, I'm not sure how much time we have.
We have 4 minutes.
4 minutes. So if you have any questions, feel free to ask, or you can stop me by outside.
So thank you very much, Peter. There are some questions on Slido. The first one is, what did your designer and analyst use to generate that huge graph of stories in a company?
I'm thinking so we exported a NetworkX graph into GraphML, and then they use some open source software, but I'm not 100% sure what was the name.
Okay.
I'll configure
You
it
can
later.
contact him.
Yeah.
Yeah.
Sure, let us know and we'll figure out. It was a nice solution.
Have you tried combination with R programming language?
No, because
No.
we wanted to have everything on a single platform, on a single code base. What's really nice about the pandas is that it mimics the syntax and logic of R, right? So there was some overhead at the beginning when our analysts, they needed to learn and switch from R to Python, but right now it doesn't make any sense for us to do anything in R because everything is covered in Python.
Okay, thank you. And you said you are data analyst. So how many hours do you spend with programming?
In the meantime of founding this company, I had to become something like a programmer, intermediate programmer, because we didn't have a lot of programmers at the beginning. Our first programmer actually joined in the seventh month of our of the origin of the company, right? So for first 7 months, it was only analysts. Right now, I spend some time programming, but we have a team of 12 or 15 developers, which are more skilled than me. So I'm stick with the product management and doing the interim CTO.
And did you consider finding interesting stories top to bottom, starting at the root of the graph and only evaluating children if their parent seems interesting?
Yeah, this is a solution. Every time we say we have a problem with the performance, someone suggests, yeah, you should look only on the top, and then if there's something happening, you should analyze it below. But the problem is, as I said, if you look at a stable company and on their sales, you would say, okay, nothing is happening on the level 0, so it doesn't make any sense to drill down. But the problem is that when you drill down, there is something interesting going on. So we really have to do every combination. We really have to look at every combination to figure out if something interesting going on or not.
The very last question, are you hiring?
Yeah, we are still hiring.
Okay, thank you very much. This was Peter Fedorochko. And now your favorite break is going, lunch break. So see you 10 past.
Thanks.
So see you at 10 past How was the lunch? Excellent. Okay. I hope you rest well. And now let me welcome Chris Swart. He will tell you he will help a presentation about documentation crash course for developers. And please don't forget to put your questions on Slido. #PyConSK. So, it's your turn.
Thank you. So, it's just after lunch on a Sunday afternoon. I'm not going to be one of those speakers who ask you to get up and move around, but instead, I am going to make you do a little bit of work and ask you a very simple question. And when I use project, this can mean product, project, library, whatever. We're just going to use a generic word, so a bit of code, a collection of code, basically. But what's one of the first things that you will look at when you find a new project that you're interested in? Anybody? Oh, yeah. It's a bit of a trick question, I know. And even those of you who didn't answer, I would guess it's at least in the top 3, the things you look for. Documentation of some form or another to understand what something is, what it can do for you, and how to use it, how to get started. So setting a little bit of context about why is documentation important, and what is good documentation. Firstly, I've got a quote, unfortunately from the creator of Perl, nothing to do with Python. And my admittance is that I am not a Python programmer at all. I'm a documentation person, of course, but this is a quote from the creator of Perl that documentation is complete when someone can use your project without having to look at its code. And I will grant that there are quite a lot of times when you maybe just want to look at the code because you just want to, but I'm also probably assuming there's a lot of times where you read something, didn't understand it, and had to look at the code to understand it, whether you wanted to or not. It's not uncommon. So we all know that having something that's understandable is important, but really, most of the time, it feels like this. This is a quote I had from someone who works at the Wikimedia Foundation, who I just met at a conference, and I thought it was a great quote. I wanted to include it, that documentation is like housework. It's something we all know we should do, but we don't really want to. We'd rather be doing something else, unless you're sort of a crazy person like me who actually likes doing documentation and doesn't like coding so much. So most of the time, it's something you feel like you should do, but you don't really want to. You'd rather be doing something else. So this presentation is basically a little bit of a run through my quick tips on how to make documentation better without too much effort, and some ideas and things to try. And a little bit of an introduction also to kind of the technical writer's tool chain. We are sort of halfway to programmers, so we have our own sorts of likes and dislikes and frameworks and tools that we argue about which one is better than the other as well. So we'll cover a little bit of that too. So first, I'm going to start with my kind of 3 W's. You have to have a sort of something to remember. So this is something I've made up to get people thinking in the first place. And this is, who are you writing for? What are they trying to achieve? And then why are you writing this? And actually, in some respects, especially with commercial projects or projects that are bigger than just a library you decide to make in a kind of a weekend, it's probably something you've thought about already, actually. It's a business case, it's a use case. And maybe if you're part of a company, you've had UX people, product designers, etc., already think about some of these questions. And actually, you can carry them through to the documentation too. Why? Oh, sorry, I'll start with the who. Who are you actually writing this for? Is it for someone who has, and actually these questions have different answers depending where you are in the documentation. So for example, a getting started guide, you can probably assume that someone doesn't really know much about the project yet. So that's a different sort of audience than someone who is then looking at reference documentation, API documentation, where maybe they understand a bit more and want to know a bit more detail. So there's different who's at each stage. What are they trying to achieve? Again, this will vary depending on the project and how complex it is and what you can do with it. Projects that are very flexible, obviously have lots of different use cases. a project that has a very particular use case has less use cases, so you can probably have a better guess about what they're trying to achieve. And then the final one, why are you writing this? I suppose this is because sometimes I've actually found in a lot of companies I've worked at, it's not actually a lack of documentation that's a problem, it was a lack of clear documentation. I've worked at lots of companies where the first thing I've done is get rid of half their documentation because it's been added to time over time by different people, and you've got a very hard to understand, hard to navigate mess. So actually before writing anything, do you need to? What's its purpose? Is it actually needed? Or are you just doing it because you feel like you should? So, and in a couple of places in this presentation, I will actually bring up this concept of sometimes less is more, actually. So diving down into these with a bit more detail, my first statement is assume nothing. There is a slightly rude, offensive phrase that I won't mention, that assumption is the mother of all something-ups, and it's true. And we are actually very guilty of this in the technical world as well. We assume that everything that we make and do is standard or normal, and that surely everyone else does it. And surely that this tool chain that we use, surely everyone else uses that. They just got it. I don't need to tell them they need to install X, Y, and Z. They should have it. Surely they've got it. I've got it. He's got it. Why haven't they got it? So my first question would be assume nothing. Don't expect that everyone does have the tool chain that you expect. And equally, don't necessarily assume that your way of working and your way of coding or creating a project is going to be understood by everybody. And this especially applies these days where a lot of programmers don't always come from university backgrounds or formal education and have learnt as they go, and may not have a lot of context behind things like design patterns and more conceptual programming that maybe you've had if you've been educated in a university. So this may start to sound like a lot of work, but actually not only does it start to make it easier to then explain what you want to explain, but it also starts to breaking down your own assumptions is actually a good way of understanding things as a whole anyway, and also just starting to pick apart something you've worked on. My second statement would be refine your concepts, maybe. And this would be, I would say, start by writing a simple explanation about what the project does. And I think actually here we can learn something maybe from the kind of startup world of like elevator pitches. I personally feel, and this might be a controversial statement, that anything, no matter how complicated, can be broken down into a simple explanation. Okay, it's a simple explanation. It's just a brief summary of what something does, but it gives people an idea of, is this for me? Is this useful to me? And if so, they'll look further to find out more information. And granted, there are some people who are very good at creating complex code, and there are some people who are very good at explaining it or selling it to people. If you're not one of those people, then find someone who is. There's an increasing amount of technical writers, technical marketing people who will help you just refine that concept and make it, just nail down that use case about very briefly explaining what it is you're trying to do. And yeah, especially in academic circles, you often find that people say, no, I need 2 hours to explain it. 2 hours is the minimum amount of time I can have to explain this. Like, I actually think you could just come up with a 30-second summary of what it is, and then you can go into more detail if people are interested. So, second controversial statement is API docs are not always enough. I say this because API docs are kind of an explanation of the tools. They're the explanations of the different bits and pieces of the project and what they do. So this endpoint does this and returns this endpoint does this and returns this, but they don't necessarily explain how people can fit them together to do something. So if you have API docs, great, fantastic. But I would also suggest you have at least one sort of getting started guide to make people understand how they can assemble these API endpoints to something usable and useful. this actually does vary per language. It's quite interesting. There's been some analysis. I think a lot of this report, and I'll refer to it again soon as well, came from the University of Potsdam, just outside of Berlin. And they did some research of how different language programmers read documentation. And for example, Java developers, possibly because they tend to have been around longer, and it's a much more established language, tend to go straight into API docs, and that's all they need to know, because the paradigms and the ways they work are kind of fairly set in stone, and they can get what they need from that. Whereas, for example, JavaScript developers, a newer language, a less established language, the developers tend to go more for getting started guides. Python, I'm not sure. It's probably somewhere in the middle. And in fact, even though I'm not a Python developer, I should say at this point that the Python community and the Python tooling is probably some of the best. And I'm not saying that just because I'm here. I say that in all my other talks too. So it's a good community for documentation anyway. So it's already got a very strong plus point. Secondly, it's not a manual. Another interesting outcome from this survey was that there are a few cultures, mostly Asian cultures, who do actually read instructions from start to finish and then go and do something. But most of the world doesn't, actually. We tend to look for something we want, we jump away, do something else, come back for what we want, jump back and forth, and we don't follow things in a linear way. So this kind of says that you can't assume people are going to read things in a certain order. So, and this is especially problematic now in that a lot of people, despite what you may add to your documentation and your website, they don't search it. They often find the results through a search engine. So you've no idea how people have even ended up on a page anyway. So if they needed to do 3 steps before the step of the page they're on to get to that point, then there needs to be a clear way that people can do that. This can be a side menu or just a kind of summary of steps at the top of a document. It largely depends, but basically the take-home point here is you cannot assume that people, again, you can't assume anything, basically. You cannot assume that people have read what they need to know already. If you have a product, maybe a hardware product, for example, that people have to do things in a certain order or it's not going to work, then you can find ways to onboard them properly. And this is almost a little bit more of a product decision from sort of product designers too, about that way of getting people the right steps they need to get started. But with software, mostly, it's kind of great if they would do things in a certain order, but it's not completely essential. But if they need to authenticate or something like that, make sure there's easy ways of people being able to get back to the steps they need to do. One of the next interesting steps is interactivity. We are now mostly writing documentation. We're not writing print manuals really these days. Even ebooks, you can theoretically add some sort of non-text. And especially for less experienced programmers or younger programmers, have actually found that adding interactivity to documentation helps a lot. It actually really, really helps. Found a lot better understanding, a lot better interaction with the documentation, and a lot less kind of questions asked about those problems. So documentation in this case isn't just text. So you can do a number of different things, and I'm going to show you some examples. These can be embedded examples or interactive examples, API browsers that you can experiment with, or even if you haven't got the time or the technical resources to make something like that, videos or animated GIFs are also very useful. And videos especially are very popular with, again, beginner or younger developers. More experienced ones tend to find them frustrating because you just want to browse through something to find what you need. And there are actually players that can support that. But with less experienced developers, videos are really, really effective. So here's an example of when I was working for a database startup, and we had like a fake JavaScript console here where you can enter a query, change it if you like, hit enter, and it's all fake, of course, but it looks like a real console, and people can actually try the syntax and see what happens with the response. This took a little bit more work, but it was quite effective, especially because one of the plus points with this project was its flexibility and speed. So it was a way of showing how quickly the results were processed too, even though it was sort of over the web. Then in JavaScript world, you have sort of wonderful things like JS Fiddle, which is an embedded service, but you can actually jump into the code and play around with parameters and watch results change live-ish. There we go. And just get an idea of how changes affect output. And I'm pretty sure someone is talking or has talked a little bit about the Jupyter notebooks, which I think is a similar sort of concept in the Python world. And finally, and interestingly, there's actually one of the Apiary developers here. This is actually an example from Apiary. So this is an API console they have where you can, I don't know if it's very clear, but you can put in the parameters for the endpoint, issue the query, and again, get results. I don't know if it's very clear, but I think you get the idea. You've possibly seen it before. And these are all very, very helpful. Picking the right examples is a challenge in itself, but, and also if you're going to do certain ones of these, like especially the first one, you have to think about test environments and things like that, especially with the database. You have to make sure people can't drop the database and things like that. But yeah, but if you could get this right, it's a very effective method. Okay, let's jump onto language. What are my language tips? As you can probably tell, I'm a native English speaker. This gives me a lot of advantage in this world, but I'm going to give you a few tips. And I'm hoping that some of them are transferable to other languages. I'm not sure, but we'll see. So, my first one is involve the reader. This is an interesting one. I was actually skeptical about this myself to begin with, and then through sort of experimentation and trying it myself, I realized not only did people actually prefer the writing in the long run, but actually it made writing it easier too. So whilst we tend to think that writing with a kind of more user-focused approach can wander into being patronizing sometimes, if you get it right, it can be a very effective way of making people feel like they're going on a journey with you, which I know we're not writing fiction, but you can actually make something interesting to read. So here's an example. Function takes parameter x and returns value y. It makes sense, it's clear. Okay, it doesn't say very much, it's just an example, but you get it. What about this instead? You can use function to return the value of y based on x. Okay, it's not a massive difference, but it involves the reader a little bit. It is kind of telling them that they can accomplish something. And whilst this is a very simple example, kind of in the long run of using this in more complex things, it can actually help people feel like they're understanding something better than just the kind of more dry language. Now, there's more that we could do to improve this, of course, and it gets more complicated the more complicated the example. But try doing things like this. And another little tip I'll throw in is that try to be consistent. Whether you want to say you or we, as in you're taking them on a journey, be consistent. Whatever one you choose is up to you, but don't mix them. Just pick you or we and then stick with that. So just getting into linguistics, this is an example of what is called passive versus active. And I don't know if other languages have this, but it's kind of a classic comment in English, especially in British English. British English tends to have this being overly passive. And I'm going to show you an example, and it'll sort of make a bit of sense. So again, this is the example we had. Function, but it's worded slightly differently. Function can be used to return the number of y based on x. This is essentially the same before, but it's an example of passive voice. Again, as I said, there's nothing really wrong with this, but it can come across as cold or withdrawn. And okay, in technical documentation, it's maybe not so necessary, but let's just take a more human kind of sentence, and then it will maybe become a bit clearer. So for example, holiday approval will be notified in due course. You want to go on holiday for a week, and you get a notification like this from your boss, and this is an example of a passive statement. It feels kind of like no one is really taking responsibility for anything. No one's really telling you who's doing anything. You're left a bit sort of unclear. So a way of putting this in a more active voice would be something like, the HR department will notify you about your holiday approval in due course. So now you have an actor and a subject. The actor is the HR department, the subject is you, or the subject is your holiday approval. It's kind of multiple subjects. And reframing sentences to kind of have this actor and subject means that things are easier to understand in the long run, and people feel like there's an involvement happening. And again, when I first came across this as a good way of doing things, I was skeptical. But over about 6 months, I suddenly came around to it, and I also found that when I started rephrasing my sentences, it made writing a lot easier too, actually. So give it a go. Next one, keep it short. I already kind of alluded to this. I'm not going to say keep it simple, because we are writing technical documentation. It isn't always simple, but that doesn't have to mean that it's verbose, unnecessarily long, or rambling, or anything like that. And there's certain tricks here. You can reduce repetition. You can reduce down to what is just needed and break documents up into smaller chunks. People have very low attention spans these days. And then there's shorter versions of phrases. So for example, I live and work a lot in Germany, and I noticed that German English writers tend to say in order to a lot. You can just say to. That's one classic example of just lots of little things you can do to shorten the text. And I have kind of a growing list of these. And I've edited German speakers, I've edited Albanian speakers, and I've edited Indian speakers. And every group has their own little things that they do, which is kind of interesting. But that's a whole other discussion. And this is actually quite hard. I will say this is strangely one of the harder things. There's a very often misquoted quote here from maybe Pascal, Locke, Benjamin Franklin, Thoreau, Cicero, or someone else. No one entirely knows who said this, but it's very true. If I had more time, I would have written a shorter letter. It's actually quite hard to write short, concise copy, surprisingly. Okay, structure. Now, I mentioned earlier that readers can enter your documentation at any place from anywhere. This is already hard. It gets even worse, actually. Many reports have shown from eye tracking, we can do this now on web pages, that online readers, especially of technical content, don't even read what you've written. So I've just told you all these ways of writing great documentation, and now I'm telling you people aren't even reading it. So what's the point? Well, what they're actually doing is scanning. People are looking for titles, subtitles, code, images, just things that stand out. So what you can do is you structure the document to have these breakout points that draws people's attention, and then you make sure that the important points are kind of arranged around those. So I'm just going to show you an example. This is from a site I used to write for that's a developer site. It's ad supported. So it's actually a lot more important because we want people to read the content. And this is quite a long, reasonably complicated article. And if, as I scroll down, you'll see that it's quite well structured. There's lots of headings and subheadings and code snippets and images. I don't know how clear it is here, but hopefully they'll even jump out at you. We can see bold, we can see some code, we can see different headings, we can see more code. It's quite well broken up. And if we're scanning through that, we kind of, different things draw our eyes to it, and then we see the text around it. So again, it's about breaking and chunking the content up to make it as readable as possible and as digestible as possible. Yeah. Next is consistency. I'm quite a big believer in consistency, and what you define as consistency is sort of up to you, and if you're in a bigger company, maybe your marketing department and things like that. How do you say things? How are certain phrases put across? How do you spell or capitalize certain words and things like that? And inconsistent writing can be very distracting. And the reason I mention this, you may think, oh, so what? What's documentation got to do with the sales pages? Well, actually, they're often in the same place and they're part of the same website. And even though they're created by different teams or different people, to an outsider's perspective, it's part of the same project or product. So keeping it consistent and making sure that phrases are used the same way is important. But this also comes down to more technical explanations. So for example, when I was working for the database company, it's a scalable database. So we have multiple versions of the database running in a cluster. So do we use node? Do we use instance? Do we use server? What do we use? We pick one and then stick to it. Otherwise, people might read node in one place, instance in another, and think, is that the same thing? That's kind of what I mean by consistency in technical documentation. There's often multiple terms, and none are necessarily right or wrong, but pick one and then stick with it. Okay, let's talk a little bit about tooling. I'm not going to go into massive amounts of detail because there are talks, and I have talks on some of these topics just in particular. But we're equally as obsessive, actually. Technical writing has been around for a reasonable amount of time, and we come from different backgrounds. There's people who work in enterprise communities, there's people who work in open source projects, startups, and we all kind of have different ways of doing things. So I'm going to talk a little bit about some of the options, and then which one works for you is up to you. So formatting and editing. There's sort of two large camps of ways of writing, which then determine the tools you use. Most of these, despite the two very different methodologies, which I'll come to in a minute, are usually plain text. There are some people, there's actually quite a lot of people I know who use something like Confluence from Atlassian, so wiki style, but that is still basically a markup language. It's still kind of a plain text language. I have met very few technical writers who use something like Word or even OpenOffice. There's reasons for this, which I'll come to in a minute, but often it's about keeping a separation of concerns. So you have the text and the way the text looks separated, so that the text can be repurposed in different ways to look in different ways. So, the first overarching kind of methodology, which is one of the more older ones and comes from kind of an older way of developing software, the time when you had one company that would make maybe an item of desktop software and they produced a manual, they had a help system for the software, maybe they had command line man pages, maybe they had an EPUB, they had different formats. So you needed to repurpose different bits of the same content in different contexts. And this is what's called topic-based writing. So instead of writing a getting started guide, what you actually do is write concepts. You write topics about installing on Linux, installing on Mac, installing on Windows. You write topics about configuring. You write topics about starting. And then you construct the documents based on the topics you want to display. It's an interesting one. It's sort of, I sometimes struggle to think how you can create a narrative going, because you're writing in kind of segmented chunks instead of a narrative. But especially if you need to produce content in different outputs, it's quite useful, and it means you don't repeat yourself a lot. You can have one example of installing, and that's it. If the steps for installing changes, you don't have to update it in 5 places. You just update it in one place, and it's then updated in those 5 places. So these are often XML-based formats, and the kind of common ones are things like DocBook and Data are the formats. And the tools that reflect this are often more complicated. Things like Oxygen, Madcap Flare, kind of some of the tooling. And they tend to be proprietary commercial tools. And they often tend to run on Windows only, which is annoying and also kind of shows you the world they come from. I've wanted to try some of them for a long time, but as you can see, I'm running a Mac. And a lot of the tooling for these are Windows only. So it's difficult, but it's kind of the world they come from. Then there's kind of the new world, or in my mind, it's the way I've always done it, and probably the way a lot of you do it, which is kind of, we've created our own buzzword called docs as code. And this tends to be in the kind of more plain text markup languages. Things like Markdown, restructured text, ASCII doc. Just one file, marked out in a variety of different ways, and it's basically plain text. So in terms of tooling, it's just a text editor. You can use whatever you like, really. Obviously, some text editors will give you plugins and packages and previews and helpers and all this kind of stuff, but it's basically just plain text. You can use anything. I mean, personally, I'm a fan of something like Markdown, but Markdown is very simple, and that is half of its point. You basically just kind of say, this is a heading, this is a second level heading, this is a list, this is bold, this is italic. But if you want to get into something more complex, it starts to run out of kind of functionality. Whereas things like restructured text allow you to do much more complex embedding of code inside other files and things like that. And also in the Python world, I know you have some of the amazing things you can do with restructured text. A particular documentation renderer and Python is actually test the code directly in the documentation, which only works in Python. So well done, because I've tried it in other places and you can't do it. So that's a really cool thing about the Python world. Management and rendering of documentation. So you've created it in XML, you've created it in Markdown, whatever. How do then people look at it? The docs as code movement tends to just put things into version control. Not particularly outlandish idea. The topic-based authoring, it tends to sit usually in the application, and you generate it to the web, to PDF, to print, to help pages, whatever. And of course, as it's just plain text, as it's in version control, you can start to do all sorts of other weird and wonderful things with it. The tool chain that developers use for continuous integration and testing is opened up to documentation as well. There are some specific management systems. So for example, Read the Docs is another Python project that kind of was one of the first to sort of kickstart the modern wave of technical writing. And that uses Sphinx, the renderer, and it's a free, I think, mostly, as far as I can remember, service for managing documentation and outputting it as HTML, and even supports things like separate versioning based on version control tags. So you can keep older documentation for older versions of the program and things like that. And then again, things like Apiary, which I've already mentioned, and many others. It's actually quite a busy space, especially for API documentation. Often there's companies who also sell API management tools, and the documentation functionality is bundled in as part of the price. And then there's static site generators, content management systems, or wonderful tools like Pandoc, if anyone's ever used that, which lets you feed in one kind of type of text and output it in another format. And it can do quite a surprising amount, considering even including processing Word files, which is very cool. If you've got Word files and want to turn them into something more useful, it will even do that for you. As I said, this means you can then connect it up to things like continuous integration. I have a whole talk on this slide, which is another way I try to get developers interested in documentation by talking about cool things you can do automatically. So things like testing code, testing spell checking, testing grammar, linting the documentation for advice on. There's a lot of nice linting tools like the Write Good linter, which kind of gives you some advice on passive voice, amongst other things. Koala, who not by pure coincidence, Lassie also happens to be here, one of the creators of it, is a kind of all-in-one linting tool. And you can find out more about that if you haven't already from him. And then automation. Automatically on merges into master or whatever it happens to be, generating new versions of documentation, things like that. Suddenly it becomes, and this is half the reason of keeping it in plain text, is you are opened up to this sort of world of treating it like code. If you want to get even crazier, you can do some quite cool things with automatically generating screenshots. If it's a graphical application, you can try things like Selenium and the robots framework it's typically used for testing, but you can hook it in to your automation process to generate screenshots. And I strongly recommend you look at the documentation for Plone. Again, another Python project. I told you guys do it good. And they automatically generate screenshots on every build really, really seamlessly, and it works very, very well. And then the advantage, again, of using some of these more open formats is if you're using Vim, Atom, Emacs, writing your own extensions and packages or plugins or whatever it happens to be called to suit something you need to test or you want to check or automate is quite straightforward, he says. So that's kind of a summary of my talk. If you want to recap some of this, this is a bit.ly link to a blog post I wrote that sort of accompanies this talk, and it's been quite a popular blog post, which was very nice. The Write the Docs community is kind of the flip side of the Read the Docs community, and we have meetups. I don't know where closest one to here is, maybe Vienna, I'm not sure. But if not, we have, actually the European conference is usually in Prague, so that's not too far away, in September, and there's the American conference in Portland in May, or there's a Slack group where people will be happy to talk to you. We need more Europeans, because usually I wake up in the morning and there's like 50 messages from America that I can't keep up with, and it'd be nice to have more Europeans to talk to. So join that. And just to kind of summarize, my kind of parting words are, documentation isn't actually just for developers. And this is why I say it's important to keep it clear and concise and well written. Because whilst it may be developers that mostly use it for kind of an actual active purpose, often people who make business decisions about a project that you're excited about using in the company, for example, will also look at websites, documentation to kind of get an idea of it themselves. And they may not necessarily understand it, but if it's well written and looks nice, it's going to encourage them more to also be keen and enthusiastic as you. And finally, well-written copy is also SEO. It's getting more pragmatic here, but well-written copy is also found in search engines better as well. So there's a kind of other reasons to think about writing clearer documentation. That's me. You can find more about me on my website or on Twitter. I'm kind of a technical writer for hire. I work for a few companies at the moment. I don't have any stickers, but I've got some little cards if you want to stay in touch. And if anyone has any questions, let's get started.
Thank you, Chris, very much. It was very informative. And thank you for motivating us to write documentation. And I think after this we have no excuses not to write the documentation. So let's move to the questions. The most liked was the biggest problem with documentation is that it can quickly get outdated. How to enforce docs always get updated when something changes?
Yep. So the technical solution or the workflow solution is to make sure if you go down the kind of docs as code path, it's probably easier because you can maybe keep the documentation in the same repository as the code or separate but very close. And what method you decide to take is sort of up to you. There's not really a wrong way or a right way. So that you know that you can kind of see it in front of you and you know to make changes to it when you make changes to code. Probably the best answer, unfortunately, though, is more about making sure that you make it part of a process. And you can automate this, or it can just be a checkbox on an issue or on a sprint that a feature isn't complete until documentation is written. And you can automate the check for that. So basically, your code is not going out until the documentation is written. And that includes maybe some of the spell checking and things like that too. You can actually make that break builds if you want to. So the code is not going live until the documentation is written and is good documentation. But a lot of it, unfortunately, no matter how much technical stuff you set up, a lot of it still comes down to making sure that someone sets that process up in the first place. So there's no magic answer, but just make sure either automatically or manually it's kind of enforced.
Thank you. How much time we should spend creating documentation compared to coding?
That's a big question because I suppose it depends on the project. I I could just pluck a number out of my head and say 10%, but I don't know. It really depends. It also depends on the community, the expectations of the community. So for example, I know the Python community is a lot more into having good documentation. So you're probably more likely to want to do it, whereas other languages are not so into good documentation. So I don't really have a solid answer for that one, unfortunately. I suppose as much as is important to you, and depending on if you want maybe a more solid answer, if it's a commercial product, then documentation means people will understand it and means they will use it. If it's an open source product and you want people to use it, same applies. There's no financial incentive, but there's the user base. So yeah, it's not really there's no number, but it's, yeah, just as important it is to you, I suppose.
And you personally?
Me, well, I'm a documentation person, so I spend all my time on it. Yeah, and but equally, I suppose, especially with open source projects, often at code sprints, beginners are a bit stuck on something to do. So getting beginners to do documentation is also is a good task, just to get people into the community anyway. So that's another answer.
And how to convince developers to write documentation? Say we don't have dedicated technical writers team.
Lock the door. No. Well, I guess I'm preaching to the converted in this room. But one would be, if it's your choice, only involve people, hire people, or bring people into the project who want to. Not everyone wants to. So look for the developers who do want to, I suppose. So then it takes less convincing. I suppose the only other motivation I can think of is, well, A, just trying to make it as simple as possible, but B, just that encouraging someone that if it's clear and easy to understand, then it means more people will use what they've written. I don't know if all developers are motivated by that. Sometimes people are just happy writing cool code, and if no one uses it, who cares? But yeah, again, it's kind of part of the process thing. There's no definite answer, unfortunately.
Okay. Does anybody here from the audience have a question? Okay.
You could speak to me afterwards. I'm not leaving until tomorrow. We can go and have a beer or something.
There are more questions on
Oh.
Slido, but I think you answered them already. On which stage of software development cycle you would recommend us writing documentation? From the very beginning? Or in the end?
So there's actually different ideas around this. There are some ideas that say you should write the documentation first and then write the code. There's like README-driven development is one concept. so there's also, I mean, if you're in an agile environment, you're probably doing it as you write the feature as well. If you're in a kind of more traditional waterfall model, then you might be writing it at the end. I guess stick to the kind of agile principles and do as much as you can as you go, because then you don't forget about it. It stays up to date. A lot of the best practices for code kind of apply, really.
Okay, and the last question is, do you think that bigger open source projects should publish documentation in different languages?
Yes.
Yes.
I mean, I am exceptionally lucky that I get to travel around Europe helping people in my own native language, but that's, you know, I'm very lucky that English is such a sort of universal language, but it would be great if things were available in other languages, and I think it happens, especially in bigger projects. Again, it's a really good task to get people to start with. You don't even have to understand the project to be able to translate some of the documentation sometimes. So it can be a really good way to get people started. But yes, and actually I didn't even cover that. There's a lot of this tooling has functionality built in for translations and things like that too. But yeah, definitely.
So thank you very much again.
Thanks.
See you 5 minutes after 2. again after a short break. We will continue with this very interesting presentation about teaching Python to your children. Sorry. Don't forget to put questions on slide 2. Thank you.
Hello, my name is Horst Jens. I'm very happy to be here, and I'm very happy that I got this running. I have here the same pictures on my laptop. It's the first time in my life, I think, that this worked at first try. So I teach Python to children. I do this since 11 years now. I'm self-employed. I do that as afternoon private education, like you do piano lesson or music schooling. This talk is about my experience doing that. First, I want to ask if there's a target audience for my talk in this room. I made this talk for people who have their own children or have their own computer club or the neighborhood coding teaching. Wow. Okay, so this talk is only for you guys. But I'm happy that other people are still there. Yeah, I will say most of you know possibly much more about Python coding than I do. So it's not so much about code examples or coding, it's more about my experience with teaching. I was born 1970 in Vienna, and the most cool thing to do as a child was going in the fun park of Vienna, the Prater. It has this big Ferris wheel, and at my time it had also had a lot of arcade halls that were dark halls with shady people inside, and then these machines where you put in coins and you can play a video game for a very short time. That was the best thing as a boy that could happen to me, to watch a player or to even play it yourself, and you could drive a tank or shoot at people or drive a very fast car. In normal life with 10 years you was not even allowed to drive, so it was very fascinating. And then in the mid-80s came the Commodore 64. I got one, and with that it was possible to play some of these games at home, not so in a good resolution, but still very fascinating. And of course I wanted my own games, so I tried to learn code. And there were two ways with the Commodore 64. One was to learn BASIC, and another one was to learn assembler. I managed to learn BASIC, but the games you could do with BASIC were not so fascinating. I remember doing board games, as a conversion of a board game in BASIC, and I never really managed to learn assembler because for my 12-year-old it was a bit too hard. Okay, and then fast forward to 2006. 2006, I had a boring job as a database programmer doing Microsoft Visual Basic applications, I think. And I was looking for a good scripting language. I found Python in the internet. I learned it in one afternoon, and I was instantly in love with this language. That was so cool. That everything was easy. Opening a file was extremely easy. And then, to my delight, I also discovered there's a third-party module called Pygame. This is a port of an older graphic library called STL, and it makes possible with Python to code little games with graphic and sound and joystick and everything you need. So I could recreate the games of my childhood, and I was extremely fascinated. The first thing I did was, just for fun, I made my first game. There was an example game, I modified it, and I made a game where you steer a little penguin and he has to shoot rectangular enemies. And there's a circle goodies and he can pick them up. And yeah, and a lot of little sprites, so bubbles come out of his ass, and little missiles floating around, and I had my fun doing it, and I was very proud. And I made a high score list where you record how many lifetime you wasted playing this game. And also I made a goodie which is like a weed symbol, and if you pick it up, then the shoots become irregular and then move randomly around and hit sometimes yourself. And there's a little green indicator at the top who count the time how long you're in this stoned mode. So I found this extremely funny. And then something very cool happened. I put this game on the internet. It was my first open source project that I actually uploaded and cared about. And then I discovered, to my delight, that there were people who maintain websites for open source games, and they were discussing my game. And one of them, I think it was an American, was saying, "What an outrage, how can you make a game where a hemp symbol is a goodie to pick up?" And then another guy I don't know his nationality, wrote, "You're a jerk." And I was extremely fascinated that someone is discussing my game in the internet in another country, and someone is defending my art against the unjust criticizer. And also there was a Japanese guy who had a Japanese website for open source games, and he wrote some translated text about my game in Japanese. And then I wrote him what you wrote, and he told me, yes, I made this translation. So I was extremely proud that someone in Japan was taking his free time to write about my game. So it was woo. And I decided, well, that is so much more fun than Microsoft Visual Basic for Applications. I will become a book author. At this time, 2006, there was no real book about Pygame. And I started to write my own book because I think, yeah, then I can make these games and I will become ultra rich and just making things that I like, and the money will come in and I will just make games. And I really did. I have the Python game book, and I made examples, and it was basically my own notes taking as I was learning how to navigate this library. So how, when I run into a problem like how to rotate a sprite, I researched it and then I tried to document it, and that was basically the game. Today it is still online. It's a doku wiki, but it's not in a good state because I have to redo everything because it was not very Pythonic, and also I'm now much more clever about how to use and how to teach, so it's not very good at the moment. It's still it's waiting, laying around until I find time to really do it. One thing I discovered also as a wannabe author is I care a lot about free software, about open licenses, that you share knowledge. And I discovered that at least back in 2006, it was very hard to find publishers, book publishers, who understand the concept that if you put a code in the book, that this code is free licensed for everyone. So all the publishers I spoke with told me, yeah, you know, this is our book, it is owned by us, this is our intellectual property. And also the other authors I know in Vienna, some book authors also from Python books, and they told me, yes, you can use my code, it's no problem, but don't tell my publisher because he owns it. So, and I think, well, this is a very silly business where all the business model is based on restriction of access to information. So I decided I want to have nothing to do with them. And the only guy I found out by researching is Richard Stallman. He managed to convince the publisher of his own biography that they sell the book, but still put the full content of the book under a free documentation license. You can actually read about that in the second book or in the first book in the end note. But well, I'm not him, so I think I would not be able to convince that. And then yes, I was stuck with a book that was not very finished, and I already had left my job. I visited my first Python conference in Geneva, 2006 in Switzerland. I spoke with Guido van Rossum. I asked him, hey, can you write a page, introduction page for my book? And he said, yes, of course. And so that was extremely cool for me. But I discovered this is not a good way to make money. And so I reverted to that what I always did for making money as a student. I was giving teaching as a training for adults. I usually train for Microsoft Office or Visual Basic. And I did that, but this time I also did that with little children, first by accident, and then I won a national competition. And I think, wow, that's actually far more fun to teach children than to teach adults. And I become a Python teacher. And I don't teach Python exclusively. Here are some honorable mentions of other things that I found useful, especially if I go into schools and have a workshop, so where you have only a very limited time, like a day or a half day or only 2 hours. And I found that Scratch, it's a visual programming language, is very useful to just get some coding done with kids. Problem is, at the moment, it's based on Flash, Adobe Flash, so you need a browser where every browser has Flash correctly installed. Also very useful is BeetleBlocks. It's a bit like Scratch. It's a visual programming environment, but in 3 dimensions, so you can make a 3D. Basically, it's a 3D turtle graphic, and it has this extremely cool feature that you can save what you coded, and the saved file can you put directly to a 3D printer, so you can make children design their own trinkets or own pieces of hardware. Also, I try to get more involved with Go.Engine. It's a South American game library that got open sourced, and it is not running with Python. So it has its own scripting language that is not exactly Python, but it is very Pythonic. So if you look at it, you instantly understand it. And it has the feature to create 2D and 3D games, but it's still open source. Also nice to have is if you have children who own an Android phone or Android tablet, you can use Pocket Code. It's an open source lab. It's also for visual coding. You swipe blocks of code around, and this allows children to use to create their own apps very, very quickly. It's a very cool project. The guys also from Austria who invented it, very, very nice people. And generally, there are a lot of people experimenting with JavaScript, reasoning that in most Schul environments, there is already a web browser installed. The web browser usually runs JavaScript. So even if you're offline, you can do certain things with JavaScript also for game programming. I'm not fully, I have not so much experience with JavaScript for teaching, but I know that this is gaining more and more popularity, and I will try to get more involved into this direction. What I do and what I have good experience with is using Python 3 and the full modules. The first is Turtle. Turtle is inbuilt into Python. It's a good documentation, a great way to teach children to use the Python or to make use out of the Python documentation. With Turtle, you can make logo-like graphics. You just need to open your terminal or idle and say import Turtle, and then you can create drawings. Another thing I love very much is a third-party module. It's called EasyGuy. It's how should I say? It's an easy way to use Ticker-Inter GUIs. With that, you can make little message boxes, and the message box can contain a graphic. So without any classes and without any object orientation, you can in one line make a GUI that looks somehow like a real program, and you can do procedural programming with that. Then I love Pygame, not because it's so good, but because I have most knowledge and most experience with it. I wish there would be a more modern version of Pygame, something that was also advised, I think, in the Python. Game engine. You can make games. There is also a very good tutorial on the web from Richard Jones about a Flappy Bird tutorial game made with Kiwi. I must say that Kiwi is not Blender. It's open source 3D software. Originally, it was video editing software, and the cool thing about Blender is you can make all kind of 3D stuff. It has a game engine shipped inside Blender, which is extremely cool, and it has Python shipped inside Blender, so you can script your own 3D objects with Python. So once you start teaching Python, you can then very easily go to Blender, or the other way around. There are also tutorials around for Blender and learning Python directly with Blender. One thing I discovered is useful to work with Schools is FreeCAD. It's a CAD software written in Python, I think, and the cool thing is if you're a geometry teacher or you want to create 2D or 3D printings, you can either draw them like with Paint, with a drawing program, and the program automatically generates Python code, or you can do it the other way around. You code like make circle or make line, and then you see it drawing. So you can do both ways, and it has, if I'm correct, also an output for a 3D printer. So it's a bit easier to learn than Blender, but also very powerful. Those are the tools of the trade that I have made positive experience with. But please, this is not an exclusive list. There are tons of other libraries out there and tons of other things. So here you see one student of mine doing some turtle graphic. As you can see, we made a loop where he made rectangulars with different colors, and then each time in the iteration the rect got bigger, and you can see he's very proud of himself. Yeah, that's more turtle graphics. The thing about turtle graphic is that what I discovered, it is possible that you make games with it, but it becomes boring very quickly. So if you're not a mathematics or a geometry teacher, then the amount of fun you can squeeze out of normal kids age 10 to 15 is limited. It's good for some 2, 3, 4 hours, but then you should advance to another topic. This is the Easy Guy game. One of my students won a national computer art competition with it. As you can see, he made a little graphic. I think he used Paint or GIMP for it. And then he put this one graphic inside a message box, and the message box can have several buttons on the lower end. And with that, you can make very easy adventure games like you're in a forest where you should go next, left, right, backwards, and so on. So you can use procedural programming, and it still looks somehow good. It's very easy. Yeah, then Kiwi, here we tried to make a hangman game with Kiwi. It was possible, but it was with an older student, and I personally have no experience teaching Kiwi to young students. I think it's possible if you know exactly what you're doing, but I personally reserve it for older students who have a bit more experience, especially because there's a split between design and code. So maybe for students who already know HTML and CSS and can split that. Yeah, with Pygame I mostly make little games like that, games that I love to play as a child. You see here a game where you have tiles and you can move the penguin across the tiles, and then you make free a picture. Yeah, and these games can all be found on my GitHub page. And the thing is, I'm be able, if the students have some knowledge, and yeah, I have two kind of courses. One is that the students come once a week, like 2 hours a week, if you have guitar lessons. And another thing is if there is a spring break or a holiday vacation, then the children come 5 days and 3 hours per day. And in such a week block, I can make such a little game with them if the students are not the first time here, if they have some basic schooling. So I love Pygame very much for this purpose. Another thing I invest a lot of time into it is to promote free games. I partnered up with Free Software Foundation. They are very active guys in Vienna. So we made big poster and we go to Game City. This is an annual meeting about computer games in the townhouse of Vienna. And we tried to promote the idea that there exist free software games, because I think this is the most important tool to motivate and also to introduce young people to coding. That you say, look, you don't have to pay for games or be content with the free-to-play games that they exist. They're actually free software games, open source, free software, and you can take everything that you find in this game, being the graphic, being the music, being the code, and you can modify it, you can make your own game out of it, and the most valuable thing, like Zero AD, you can actually get involved, even if you're just 14 years old, and can try to do something useful and give this usefulness back to this project. So you work at a worldwide project where everyone can profit from. And I think this is for minor age people, also for young people, that they can participate in an adult project with other adults around the globe at a really cool project. This is something very, very cool, and sadly it is not very well promoted. But such games exist. Another game here I love very much is Dungeon Crawl. It's an open source game, and of course I can use all the tiles, the graphical tiles, to make my own games with my students, which saves a lot of money and time, because we don't have to paint them ourselves. Okay, if I run into new students who never coded before, I usually just play around a bit with idle. I hope you can read it here. Basically, we made a small oracle here where the endless loop, and sorry, it's a 10 loop only, and you can print a question in the text console, like does Thomas love me, and then the computer will answer yes or no. And little children have tons of fun with that. I find it a bit boring, but I learned that it's for them it's not boring that the computer answers their questions. So, okay. You see, I usually have groups of max 5 or 6 people because I have 2 tables in my office, but one table is full with my own stuff and I don't want to clean it up. So I group all my students around the other table, and sometimes they bring their own laptops, sometimes they take my laptops, and then we try coding as best as we can. I have sometimes girls that I'm very proud of, but sadly they are not more than 50%, and usually only in vacations, not during Schul times. Yes, the students come with masks because it was carnival. The more students, I don't even know why I have this picture. Okay, this is a fake picture. These are not students of mine. They were in my office, but as you can see, it's all girls. So it's this was a day of the city of Vienna called Daughters Day, where daughters are encouraged to go to offices and look for a job. And so I got a lot of requests that girls can come and see one day how it is to work here, but none of them become students of mine. This is more a normal vacation course. You see one girl, 4 boys, and having fun. Yes, also that. Okay, what I can say is what I try to achieve if I teach coding. I have no academic training in coding. I'm a heating engineer I can calculate a cooling pipeline. So what I try is to let the children do something that they're proud of. Like you can see here, this little guy is very proud and completely ignoring his sister and his mother, but they are also proud of him. I think he created something with turtle graphic or so. And if I manage that he did something himself and some goal that he maybe did not even was aware that he had this, but then he managed it and to achieve this, then they're proud and then they also come again and again because I'm paid by the hour. So if I teach in a bad way, I have no students and no money. These are also 3 students of mine. They made a game together. The middle guy had an art background, so it was a music game where you have to be in the rhythm and you steer these little triangles and shoot each other, but you have to do it to a beat of a music. That was important for them. And I think they sent it to a national competition. I'm not aware if they won. I think they don't won. But anyway, you can see they're very proud that it was, after 1 week, playable. Okay, sometimes I go into Schuls and make workshops for Schuls, usually to attract students for my private courses that actually never worked, but I still do it. The teachers are very happy because I teach there for free. Sometimes they try to collect money. And what I do is I try to build friendships with teachers that I like, that is always useful. And I try to look a bit how the teacher teach, because especially older teachers have much experience. And this was a teacher in Carinthia in the south of Austria. From him I learned two very useful things. One was, if you can see, some children here have tape on their mouth, because he has the problem that maybe every parent and every teacher has, that it's too noisy and he cannot teach in a meaningful way. As in the computer lab, as it get noisy, he put out a big scissors and tape and said, who wanna tape? And the children really lined up to get their mouth taped and then got back teaching. And then they tried to communicate, but the noise level was reduced, and they have some internal ranking system who managed to long as to have his lips closed. So I don't know what the award was for being the last man with closed lips, but the children clearly, as you can see here, enjoyed it, and it was more silent. Another cool thing that this teacher made is he recognized that it's very boring to sit all the day long and get taught. So he tried to move his kids as much as he can. He got to gyms and to these muscle building facilities and get machines like treadmills and get these machines as gifts in his schule, so that the children in the break can train and move on them, and sometimes he even tried to teach them while they were making movements. And all of his children, I have videos of that, all of his children were able to juggle at least 3 balls simultaneously with age 12 or so. I'm age 47, I can't even juggle one ball. So this was extremely fascinating for me, and I think it's a good way to keep the children more peaceful. Yes, this is something what never fails. Here you can see two important lessons. The first is, I think you know that how to multiply a string. The text is in German, it means I'm Vanessa, and then the second line is I'm the boss. And if the computer writes 100 times that you're the boss, this is a very big ego boost for a little child. What is more important is, and I learned that by accident, because once I was playing around with the colors of the terminal, and then the children said to me, now we're hacking, and I did not understood it until I got the message, if you do something with a green font on a black terminal, you're a hacker. And then you're cool, and then it's fascinating suddenly. So always, first thing, change the colors of the terminal, because then they're real hacking. Okay, second thing I learned, I have from FOSDEM, I think I bought one stuffed Python. And this Python is very popular and help my children to code, especially if it rests on the head of a student. You see this guy is extremely relaxed. The other one less so, because me, the teacher, is doing something with him, but the other one get help from the stuffed snake. That's extremely important. Yeah, more stuffed snake pictures. Yeah, sometimes what I learned is to respect children even if I don't understand them. So they have very short attention span, but also they're very flippy. One day this is important, and the next day something completely other is extremely important. So I learned to not make any lesson plans, because they don't survive contact with my students anyway. I try to be well prepared in a general sense and have experience. And this student came to me and said, here's now a Raspberry Pi, and with his pocket money he bought a little screen that he can attach to the Raspberry Pi. And then we managed to install Linux, because he wanted to have his own pocket Linux that runs on this Raspberry Pi with this little screen. I don't fully understood the purpose. You have a very small computer with a very small screen, but he was extremely happy that it worked. So what we did, we printed out the tutorial instructions from the internet and tried, and we managed it in 2 hours. So I made him happy. Of course, I think he did not learn coding, but maybe he learned something else. It's something it was for him, this was the most important thing in the world, so I did that. Okay, as I said before, I try to get the children my students into doing real world adult stuff, like working with Git, like trying to participate on an open source project, mostly computer games, but also here I had a reporter from the National Austrian Radio, the lady, and she interviewed my student, and as you can clearly see, the 8-year-old was not very much interested in her questions, and he was playing his own game that he coded some minutes before, and she asked him something like, what is it that is so very fascinating with coding computer games? And he said, typing. The little girl with the hat is another student of mine, and the other guy is Derek Breen, the author of Scratch for Kids. He's an American guy, very cool guy, and he was living at my place for some time. So my student interviewed him in English. It was her first interview with a famous author in English, and then we published it in the net. This was also not exactly a coding interview. His book was about coding, but for her it was extremely important, because now she was with age 15 or 14, she had her first interview published. So I try, if I can manage to give them experiences that are good for their career, that are adult stuff, and I try to show them, look, you can do something that other adults do. Yes, yeah, can you see that? One student of mine was trying to make a little spaceship, and it should fly a giant 8. And he had no clue about vector mathematics, so I made him calculate the points, that the flight path is in a coordinate system. And then we managed it. You see here the little spaceship clearly flying an 8. And for him that was extremely fascinating. Also for me that was kind of boring, and I could have shown him 2 functions where he made that quickly, but then he would have had no clue why this works. So I made it in a bit more complicated method, but a method that was corresponding to his level of mathematical understanding. Yeah, What I also learned is even if lesson plans, at least for me, does not work, it pays to have good examples like proto games where something works. Like in this proto game, you have tiles and you have sprites that fly around and they can shoot. And then it's very easy for the children to change the amount of bullets that come out of a penguin or change their colors. So to give them something to do, even if they have very limited knowledge of coding, that at least some play field or sandbox that they can modify on their own. They have sometimes very surprising ideas what to do with them. Yeah, summary is that don't copy my model of business, except you want your mom every day asking you, son, doesn't you think it's time now to get a real job? And it's, even you see here, I'm clearly, I think I'm more wise and old and experienced than my little students here, but they managed, each day I met them, they managed to ask some question I had not thought of ahead, so I had to very quickly find a solution to some problem or question they made. So it's you have to be flexible. But sometimes I have groups like that, all students, all occupied, clearly all engaged. And if it works really very good, they learn a lot from each other. So I encourage you to have groups from at least 3 or 4 people. It's actually a bit harder from the logistic to teach bigger groups, but it's very much more rewarding because you have to teach less. The children teach each other, mostly passive. I don't fully understand how this concept works because I noted that every time I try to teach them some theory, they don't pay attention, they don't listen, they just make jokes. So I think it's in vain. But somehow, mostly if someone of the group understood something, he brags about it, he shows the others, and then they get more involved. So it's good if students have an environment where they can learn from each other. Yeah, that's all. I also want to close with a note of Linus Torvalds, the coder of the Linux kernel. I think he's a good coder, and in his biography, just for fun, he wrote that he remembers childhood memory that he was sitting on the knees of his grandfather, and the grandfather coded, and he was just looking or somehow participating or maybe typing, and the grandfather told him what to type. And he wrote himself that he, at this age, maybe 6 or 7, had clearly no idea what he was doing. But now he is one of the world famous coders. So I think there's a lot of social learning involved in teaching to code that is not very well recognized. So if you have role models, if you have other people who you see them coding, then it becomes something for you that you want to achieve also as a child. And I think that's important, to create an environment, be it a programmer group or a hackerspace, where people can code and learn from each other. Thank you.
Our Python community from a very young age, and you teach in German-speaking country. Is there any problem with the software written in English?
There's a problem with people, students telling me they can't read documentation because it's in English. What they mean is they can't read documentation because it's written, and reading is stressful for them. So at least if I take them age 10, they know enough English to understand if they really want. But reading itself is an effort. You must read, that's something they just learned, and then you must understand, so spell correctly what you read, and then you must think. And it's far more easy for them to just watch someone or watch a video. But I myself, I had French in school, I had no English until I was 16. I learned all my English through coding, so I don't buy this argument that it's just because it's English, it's difficult.
Mm-hmm. And do you focus attention only on graphics?
No, actually, I wanted I can show later something. I think you can have a lot of fun in text mode. Text mode is not boring, and I'm a bit wary of all these online courses and online new cool things where there's good graphics and 3D graphics to teach programming. I think you need good teachers and good ideas to teach coding, but not necessarily good graphics. So you can make a roguelike with text mode, and this is fascinating enough.
Yes, I think they wanted to know if you, for example, if you tried any BBC microcontroller or Arduino.
Sometimes students bring that to me. For me, it's a problem. I I must make classes to scale my business a bit, and for that it's very hard to buy hardware, even if it's cheap hardware. If I'm not sure that I can do cool stuff with this hardware, I'm reluctant to buy hardware. So I only make this if the student already has the hardware and brings it to me.
And how old was your youngest pupil?
I think so usually I take them with 10 years when I'm sure they have finished elementary school. I think the youngest I took ever was 8 years. It was the one guy you have seen with the Arduino screen. He was very advanced of his age. Of course, every parents I meet are convinced that they're genius kids. With 3-year-old, they can code Python, and I should now do something because they sit at the computer playing Minecraft all the time and so on.
And you already showed us that you teach kids in groups. And do you prefer individual or group courses?
I prefer groups because I demand 12 euro per nose. So if I have a group, I'm more happy.
They are asking if you have any project here in Blender made by you or your children.
At this computer, sadly not. I had students who were very good at animation, but they had, with video learning or with some other tutor, some prior knowledge, and they made a dragon who was looking like this Game of Drone dragons and was animated. And what I do with new students to Blender is we play around with the Blender 3D game engine. There are tutorials out there for that. But I have nothing to show at this computer, sorry.
Do you look for other teachers?
Yes, always.
And your students are preparing also home, or it's only
I wish. No, I think in 10 years I'd never. I mean, I say, look, as a homework, you could at least finish painting these graphics, that you don't waste our time here with painting this sprite. But I don't remember that one student come to me and say, look, I made the homework. I think it never happened to me.
And the last question on slide 2 is not a question. It's thanks for a great speech. Good luck and keep up the good work. Thank you. Thank you.
continue. It's our last talk in this track. Bhargav will tell us something about how great it is to use GenSim for topic modeling. So, it's your turn.
So hi guys. So today's topic will be, this talk will be about GenSim and topic modeling. And well, yeah. So GenSim does natural language processing. And why I would recommend people to use GenSim? It's fast, it's really fast, and it's easy. And I think, honestly, these two reasons are reason enough to use GenSim. But some more reasons why it's fast is also because it's heavily optimized NumPy libraries. It's also Cythonized. And now, a huge motivating reason for me to use GenSim is even if you don't have a powerful computer with a lot of RAM, what happens is GenSim streams from memory. So it streams documents. So even if your RAM is less and you have a lot of data, it streams documents one by one. What this means is that huge data can be easily accessed and played with using GenSim. So briefly, that's why I would ask people to use GenSim. I'd also recommend those who have their laptops open to just search up GenSim on GitHub. And yeah, now I want to talk about GenSim and topic modeling and why. So the business problem is, well, data, lots of data. If all of you could pretend for a bit that you all work at a newspaper agency, and unfortunately your job in the newspaper agency is to deal with the data, you have the person who was organizing data before you did an absolutely terrible job. So you have internal documents, you have external documents, and you have no idea how to manage this data. There's no documentation, there's no annotation, and you have no clue what to do. You just have lots of text documents, lots and lots of text documents. Now, how does GenSim and topic modeling help you? Instead of looking at keywords, you can look at topics. And as you can see in this, just forget about keywords. You don't need to look up things like legal or things like that. Topic modeling on huge data sets, it creates topics for you. So what you're going to see is maybe that these are your company's internal documents, if you're working in the newspaper agency, and you would have a breakup of maybe something like this. You'd have a lot of marketing-based documents because it's a newspaper, then you'd have some engineering, some legal and customer support, and things like that. So the idea is, using GenSim, you can create topics, and you can use these topics to organize your data. Some more information, this is completely unstructured data. Like I said before, the person before you was terrible at organizing the data. But now you've got yourself this. You can create a lot of structure from nothing. Now, why else would you need it when it comes to business content? You can organize. We had a previous talk about similarity and how they used Word2Vec and Doc2Vec, at least in the other hall, about how to find out similar documents and similar queries. You can also use topic modeling for the same thing. Any guesses why? If you have a lot of documents, you can say that, okay, if two documents are going to be about sports, it's likely that they're similar. So this is another example of why you would need topic modeling. Now, for a second, if you're not going to be a newspaper guy anymore and you're working in research and you want to understand different trends, like what are people writing about? What kind of research topics are people talking about? You can actually use topic modeling to read all of these research papers and you can come up with topics, a different breakup. For example, in this case, you can see for some reason mathematicians really like curves and points, and a huge number of research papers are just about that. And personally, what I like to do is, I grew up as a big Harry Potter fan, so I just tried using topic modeling on the Harry Potter corpus. So I found out that Harry, Hermione, and Ron were words which are obviously used a lot, and you can try and find out their topics like Voldemort, like Quidditch, like Hogwarts. So the interesting thing about topic modeling, or my motivation for using it, is it's extremely easy, it's useful, and even if you don't want it to be useful, if you don't work, if you're a student like me with too much spare time, you can just find out what mathematicians like and what J.K. Rowling likes to write about. Now, a little more about what exactly topics and words and documents are. I'm just going to briefly explain it. Now, a topic model, well, obviously it creates topics. Now, what exactly are topics? Topics are just a collection of words which are organized together. Now, documents are also a collection of words, but they're not organized together. They're just words written. So you can argue that documents are made out of topics, and topics are made out of words. So a little more into what exactly a topic would be. If you look at this chart out here, now the headings, which are politics, weather, and sports, are headings which I've given to these topics. But what the topics are actually collection of words. So out here you can see that one topic would have words like conservative, Trump, and Clinton, which would likely be about American politics or politics in general. You'd have another topic which would have words like rain, sunny, beach, mountains maybe, which you could argue was about the weather. And you'd have one about sports. Now again, if you go back to an example, if you're a newspaper agency guy and you run topic modeling on all of the newspaper articles which you've done, you automatically see you can sort of find out that, hey, your sort of unstructured data is actually structured because the documents themselves tend to talk about certain things. Now topic modeling, it sort of tells you that, hey, these are your topics. Your documents are made out of these. Now, what exactly are documents, which I said are made out of these? Now, say you have these topics, and you're going to use a recipe. Now, what's my recipe? My recipe for creating a document now is it's 50% politics, 30% weather, and 20% sports. So this is my recipe. And now I've got myself a document. Now, document talks about a conservative liberal who's the president and who's talking about Olympics. Oh, these are just random words, but the idea is this document was created using a recipe which was created from topics. Now, this might get a little complicating, so I'm just going to try and explain what exactly do I mean by recipe. I mean, what is my breakup? My document, what is it made out of? So how did I come up with these topics in the first place? It looked like, did I randomly find them? No, I ran my topic modeling algorithm on my documents. So now I have a lot of documents, you can see from document 1 to document 1000, and I sort of train a Bayesian model to try and understand which words come around other words more often than others. By doing this, I can find out what topics are there. Now, luckily for users, you don't need to care what's going on under the box because you know what the end result is. You have your topics. So now I'm going to briefly talk about you know how exactly these topics come about. But what you need to know is you don't need to know this. But the most popular topic modeling algorithm is latent Dirichlet allocation. Now, if you look at this particular block diagram, you can see the only thing which is gray in this diagram are the words, which is W. Now, that's because that's the only thing you know. What you don't know is topics, and you want to find out topics. Can you see the Z? The Z out there are topics. And the theta sign out there is your documents. So what this sort of means are documents, or theta, is made from Z, or your topics, and your topics are made from W, which are your words. So sort of wrapping things up, the only thing which you know are the words, and just with the words and the documents, you can find out your topics. Now, if you want to find, if the alpha and beta, which are two parameters, are more mathematical parameters, now I'd highly recommend reading the research paper behind topic modeling. It's a really simple paper. You don't need to really know much about mathematics or about computer science to understand it. It's a very well-written paper. I just put this up to give some perspective of what exactly topic modeling is, so you don't just look at it like a toolbox, but also realize that there are some parameters that you have to play with and what's going on. But when it comes to GenSim and about how easy GenSim is, I've spoken about all these kind of parameters in Bayesian inference, but the only thing which GenSim cares about is your corpus and a number of topics. So you just need to feed in two things. You need to feed in your textual data. It can be completely unstructured, though if you do clean it up, it's going to be easier for GenSim to work its magic. But all you need to do is this. That's two parameters, your corpus and a number of topics. You can, of course, do more. You can pre-seed topics. This means that if you are working, again, as a newspaper agency person, and you know that some topics are going to be about sports and the weather and politics, you can tell the model that, you know, these are some topics which are going to come around, so you can better tune your model. You can play with more hyperparameters to decide how many words are found in one topic, how many documents, and how many the relationship and the proportionalities can be found out. But as far as you're concerned, you don't need to know about all this. All you need to know about is, I have a lot of data, and I want to know topics. That's it. Now, obviously, this is a machine learning algorithm, and in any machine learning algorithm, you want to find out if you have a rubbish model or a good model. Now, if I don't find out about politics, weather, and sports, and instead I get rubbish topics, you can instead manually evaluate them to find out which models are good. So in this particular diagram, if you notice it, this is from the original LDA paper, which is, again, like I mentioned, a really, really well-written paper. So they found out, again, on newspaper articles about these 4 topics: arts, budget, children, and education. By coloring a document, and when I mean coloring a document, you pick up each word, and you figure out which topic is that word from, and you color your document, you can have a good idea of how good your topic model is. Now, if this doesn't make sense, I'm going to sort of dumb it down again. There are two topics, a riverbank and financial bank. And now you want to find out if the sentence out here, which is bank, water, river, tree, what kind of topic is this about? So once you color it, you notice that bank is in red and the other three words are in blue. You can notice that this is a pretty rubbish topic model because bank is red and it's not a financial bank. We're talking about a river bank in this particular case. So a bad model, you can see the bad LDA parameter being passed. It's bad because I'm getting a red colored word out here, which should not happen. Instead, I can just color it blue, and you can see that a good model would give me blue words, which means that this model has been trained well. Now, of course, so basically one way of identifying whether a topic model is good is by coloring all the words in your document. Now, since we're lazy and we just want numbers and we don't want to go through the whole process of coloring a document, you can also just do something called topic coherence. Topic coherence is, again, another GenSim functionality where you can just throw in a model to your pipeline and you can identify if it's been well done or not. Basically, a higher coherence measure is a better done topic. So in this particular case, I just want to show you that you don't need to evaluate your model with colors. You can also evaluate with just numbers. It's really easy to do it, and there's a lot of tutorials and this thing on GenSim to identify how you can color your topics. Now, what we briefly learned so far is how to deal with unstructured textual data. Like I mentioned before, now you can have many reasons to want to do this. Either it's for your personal data or business data. And I wanted to show you how it's easily done with Python and GenSim. And if you go back, this is literally all you need to be doing, which is, model is equal to LDA model, and you just throw in your corpus. Here, a corpus is a collection of documents, and the number of topics is 10. So that's all you need to do to find out to topic model. Now, what else can we do with GenSim? GenSim in itself has a wide number of features. If you remember the similarity talk, which is done in the other room, they use word2vec and doc2vec, which are really popular machine learning algorithms which are used, and GenSim has implemented all of these. Dynamic topic modeling is an extension of topic modeling, which allows you to play with time. For example, if you want to know how, in a newspaper, if you want to know how topics have changed over time, you can use dynamic topic modeling. Again, why you would want to do this is text similarity, text analysis, and you can analyze any sort of text really easily. Now, another real motivation for using Python and GenSim and not any other language in GenSim is the fact that you can pretty much create your topic model and create your entire data toolkit in just 3 sentences or 3 lines of code. Your first line would be for line in open on your document. Your second would be create LDA model. And your third would be to print your topics. So basically, in 3 lines of code from all of your unstructured textual data, you have topics. It's absurdly easy, it's really fast, and it's documented quite well, which means that you can just start doing it right away. If you have your laptops in front of you and you have any spare textual data lying around, you've got topics. Now, what next? What I would encourage people to do is we try to attend as many PyCons as possible. I'm only a student developer for GenSim, but the parent company, Rare Technologies, tries to hold sprints like what Koala was doing today. There's a lot of tutorials and implementations on the GitHub page. And it would be really awesome to see more of Slovakia using GenSim. I haven't met many users of GenSim in Slovakia so far. And it would be really, really awesome to see pull requests and issues being raised and more people using GenSim. It's already pretty widely used. It's arguably one of the best text analysis packages out there, but it's also important to know that you don't need to be using English for your documents. It doesn't matter which language you use because it's all a vector space algorithm. So even if it's in Slovak, in German, in French, in whichever language you want to use it, you can use GenSim. Briefly about me, my association with GenSim is through the Google Summer of Code program, and I'm currently working in France. You can follow me on Twitter or GitHub, where I mostly talk about machine learning and data science. My French is pretty bad. I'm still learning. My Slovak is really bad, but well, dobry den. So thank you. Any questions?
Yes, there are. Some of the questions were already answered, I think, but let's get through them. Assume I do not know the number of topics beforehand. What do I do? Some kind of CV? I don't know what is CV.
Yeah, let's. So I'm assuming CV here was with relevance to the small snippet of code I put up out here. So you can try and find out which model with the appropriate number of topics has the highest coherence. What this means is that you can basically run your topic model on 10 different number of topics. So say you have a hunch it's maybe 10 topics are good, but then you're not sure. So you run a loop from 5 to 15 or 5 to 100 or how much ever time you have, and you check the coherence values, and you see these numbers. So a higher number, a higher coherence value would mean that that topic is more adjusted to that particular data set. Now, there are multiple ways of identifying how many topics you'd want. Of course, the default is 100, which is, I mean, a lot if you ask me, but it's usually depending on the size of your data set. It's more of a, it depends on from data set to data set again and again. So this is not, I can't give you an exact answer, but I could also ask you to just check out the GitHub page of Jensen, because this is, of course, a really important topic to identify how many topics is best for a corpus. So there are many different tutorials which talk about different ways you can identify. But one way is to just use these numbers. The highest value would be the best number of topics. So if you run the loop from 0 to 100 and you find that 17 has the highest CV value, it means that 17 is the best number of topics. But yeah, there is no official way to find out, but there are many suggested ways on the Jensen webpage which you can look for yourself.
Have you experienced with experiences with the non-English corpus in Jensen?
Yeah, I've used French before because I work in France right now, and possibly the only problem I face is the fact that there isn't as much corpus, or there isn't the same kind of resources, because most of the academic and industry, they work in English. So it's tough to find really good quality corpuses. But apart from that, it works the exact same way. There are no problems. I mean, there's no compromise, because again, as you know, what Jensen does, or any natural language processing library does, is convert it to vector space or numbers. So it doesn't care what language you use, and I've used it in French and English, and it seems to work quite well.
How would you compare NLTK and Jensen? Both of the libraries are for natural language processing.
Yeah, this is a good question. Of course, NLTK does very different things. NLTK is more related to computational linguistics, which would be topics like parts of speech tagging. For example, if you want to know if a sentence has nouns and verbs and how it's structured, or if you want to find out named entity recognition, like if you say Obama went to the park, then you know that Barack Obama is a person. So for things like this, NLTK is popular. But NLTK doesn't, for example, offer many machine learning capacities, which is what Jensen mainly works on. And also, because Jensen is highly optimized for industry standard, it's fast, like I mentioned before. It has the opportunity to run on multiple cores and distributed systems, and it can actually use Jensen in production. But if you were using NLTK in production code, I would be a bit worried, because it's probably not the best. There are much better, like Spacey is another really popular natural language processing library, which is, I think, better than NLTK. So to answer your question, Jensen has a different use case. It's topic modeling and word-to-vec and more machine learning and statistics-related algorithms. But NLTK is more about computational linguistics, which is a different field. So there are different toolkits for different purposes. I'm going to say Jensen is better because I like Jensen and I use Jensen, but yeah.
Okay, you were talking about paper, about some simple paper, I think. So the question is, what is the topic modeling paper you are talking about?
Yeah, I'm sorry, I should have been a lot more clear about this. It's latent Dirichlet allocation. This is the name. You can just Google search this, but a little more information about why this is called this is latent is hidden in this particular case. And it's hidden because the only thing we know are the words in the documents. We don't know anything else. And we get to find out topics and different priors, so it's latent. Dirichlet is a kind of probabilistic distribution, which it draws from to do it. And allocation is because it allocates different topics to documents and different words to topics. But this is the name of the research paper which you'd want to look at.
What background is needed in order to contribute to Jensen?
This is, again, a good question. I honestly think you don't need any background apart from basic Python, because there's really a huge variety of problems. Like documentation itself is huge, and you don't really need to be a mathematics or statistics student to be good at documenting. And I personally come from a computer science background, so I wasn't the best at mathematics, but I could easily join because there's a really wonderful support group. Most of the people running the library themselves are from a mathematics background, and they're really helpful. So as for what you need to know beforehand is just basic Python and that you'd want to contribute to Jensen. That's enough. And the issues are organized from easy to hard, and you can sort of start off with basic documentation and organizing. Or if you're really enterprising, you can go ahead and implement some algorithms. Both would be really cool.
It's good to hear it. Have you tried Jensen with Apache Spark?
No, I haven't myself because since I work in research, I'm allowed to have slow code, which is not good, but which is why I personally haven't used any distributed systems. But there is Jensen and Spark and Jensen and TensorFlow are projects. You can actually see the pull requests being done right now. What it does have is that's parallelization, but I haven't used it at Spark yet.
Can I use labeled data as seed to enhance the modeling accuracy?
Yes, you could. Though LDA is an unsupervised algorithm in the sense that labeled algorithm will not offer anything new, because what you could do is pre-seed the topics. If you know that certain words are going to appear in certain topics, you could do that. But in this particular case, at least for topic modeling, structured data would not be helpful.
And we have a question for sprints. Where are sprints announced?
Oh yeah, so you could check out, you could subscribe to the Jensen mailing list. I do know there's a sprint happening in the USA at PyCon USA, and at PyData's also we try to make our presence felt. So PyData Berlin is coming up fairly soon, and we had Katharina who spoke yesterday a lot about data, and she's the head of PyData Berlin. And Jensen is going to try and have a good presence at PyData Berlin. So if you guys can drop by there, that would be awesome. And of course, you could, to answer the question, I'm sorry, you could check on the mailing list, and you could also check on the Rare Technologies page. Rare Technologies is the parent company which works with Jensen.
Okay, when applying topic modeling iteratively, how can I better control which topic becomes a subtopic or sub-subtopic and so on? How to adjust the level? Okay,
so at least in what I've talked about, which is latent derelict allocation, there isn't subtopics, there's no hierarchy. So for example, if again, if you go back to the example of newspapers and I talk about these three topics, you won't have a subtopic under politics such as American politics. This is not one of the features of LDA. What you might have is another topic separately called American politics, which might not have the same words as politics, but they would be two different topics. But if you do want hierarchical topics and subtopics, there's a different topic modeling algorithm also provided by Jensen called HDP, which I've mentioned out here about LSI and HDP for more topic modeling. HDP stands for hierarchical direct processing. So you have a hierarchical approach to the way you approach topic modeling. In which case you do have subtopics. Unfortunately, I still cannot answer the question because I'm not very familiar with HDP. So I've not worked with subtopics and hierarchical topics. But at least in the context of normal topic modeling, the most popular algorithm being LDA, you don't have subtopics. You may have multiple topics which are similar to each other. You can actually identify similarity of topics as well. But there's no such thing as subtopics. It would be topics, and if there are 10 topics, 10 different topics.
Okay, thank you. And the last question is there a version of LDA with online learning in Jensen?
Yes, there is. You can do online learning. There's an algorithm by Hoffman and co, and LDA and Jensen has adopted it. So again, you can just go out to the GitHub page of Jensen and check it out. It's really cool.
Okay, thank you very much.
Thank you, guys.
This room in this auditorium. So if you want, you can move to large auditorium. There will be one more talk, or if you if you travel home, if you're from